All right, so there we go, guys. We're recording 25th of April, and tonight we're going to be doing Module 7, which is our subfloors. So there's a lot of stuff that we're going to cover tonight. We'll start off with, you can see on the screen there, doing different subfloor vent requirements. So we'll touch on that first about where we actually have to put our vents. In relation to our subfloor system, then where they've got to be spaced, and then basically how big those vents need to be. So we'll basically cover a little bit of that, and then there'll be an exercise that we can do. If you guys have done this unit before, which I'm sure a lot of us have, I've actually got an exercise which I did up today, so you guys can actually do something new as well. But when we do this subfloor one, you've probably already done that one, but we can change some of that for your own scenario and just make it a different soil classification where you guys can then work out what size Rio needs to be in your strip footing, how deep, how wide, and things like that. So yeah, but once we touch on that, I'll give you guys something a little extra you can do on that. But I thought we'd start by just showing you here, for the guys who aren't familiar with subfloor vents and actually how they work and what they're for. And I'll email this out. I don't think this would be something you guys would actually have in your books. And I don't know how I came across it because it's not actually in my book either, but it's on my USB from builder registration. So what we're looking at here is basically showing with our subfloor, and this comes out of our Australian standards, which will actually cover in about another 2 weeks, I think, when we do our masonry. And it basically shows how it has to be no further than basically 600 mil from the corner. And when we come down here, this is probably, I'll just make that a little bit smaller. That looks all right. So I don't know how clear that is on your screen, but basically what we've got here, guys, we've got some engaged piers and then double masonry on the outside. So if you haven't seen this before, basically the vent would go there and blow all the way through so the air can circulate, but it doesn't actually blow into that engaged pier. I'll bring up a little picture that shows it from a plan view. Just bear with me 1 second. All right, so this here is the answer guide to what we're going to do a little bit later on. And as you can see, like looking from above, these red squares here are our engaged piers. So it shows you, admittedly this diagram's only got one skin of masonry on the outside, whereas this one's got two, but it's the same scenario. So with those vents, they would be placed on either side of this engaged pier. So that red square is an engaged pier, which is what this part here is what our bear is sitting on. And so we need to have vents in our external brickwork so the air can circulate and get in under our subfloor. So don't be confused by that and think, geez, that vent is just going to blow straight into that engaged pier. Because when you look at it from the plan view, we would offset them so they'd be placed here somewhere and then be able to flow through, and actually they wouldn't butt into what that engaged pier is. So we'll read through this. And it says, so vents evenly located around the perimeter and within 600 millimeters of the corners. Vents needs to be sized and spaced to provide 6,000 millimeters of opening per meter length of wall. So we'll talk about it a little bit later on, because depending on our climate zone, whether our soil's protected or unprotected, then determines on how big our vent needs to be. So you might find they're the same, they're a standard size, obviously maybe the size of what a brick is, but the actual amount of air that passes through those will actually vary. And I'll get to that in just a second. So just to give you an understanding, we'll read through this here. So the aim of the subfloor ventilation system is to provide cross flow of air in both directions. So, for example, from side to side and end to end of the dwelling. Vents shall be placed in all walls that enclose the subfloor space. Corresponding openings shall also be placed in any internal walls in the subfloor space. And to prevent the formation of dead air pockets in the subfloor space, vents are to be placed within 600 millimeters of corners of each wall, and then required spacing between. Vent spacing should not exceed 1,000 millimeters. So don't worry too much where it talks about our internal walls. That's not something that we cover in this course or anyone's ever been asked it in the VDA. But that's what it's sort of showing here. But our scenarios where we find the guys get tested is ones like this. And because you've got all this airflow underneath, then you don't have to worry about putting them in these internal walls so it can pass through. Because obviously in this picture here, it can just pass through basically where these stumps are. So just getting to the next little part. This is an example of different vents that are available on the market. Now that might be too small. Don't stress, you're not going to have to remember these. So this is just a little bit of an exercise so you guys can sort of put 2 and 2 together and work out how they work. So you're not going to have to remember, have an exercise and go, oh geez, which vent am I going to use? Am I going to use the clay one that's 160 by 230 with 8 slots, or one with 15 holes? So you won't be asked in that much depth. This is just something we've given you to put a bit of context to when you're working out basically these vent requirements. So when you look at it here, this just tells us different vents that are available. So you can see them all down here. And basically what it tells us is the material that it's made out of. Some are clay, some are metal. It shows you what it actually looks like. And then it tells us what the vent size is. So then tells us here what the vent pattern is, how many holes or how many slats it's got. And then it talks about basically the ventilation area per vent in square millimeters. So this one here gives us 4,800 square millimeters of vents. When we come down, this big one here is 13,360 square millimeters. So the reason we actually need to know that is when we go to our building code, and I'll just bring that up and show it to you. Bear with me a second while I just bring it up on the screen. So this is out of the building code. And when we come to so this here tells us, that's our subfloor openings and ground clearance. And it talks about basically the minimum ventilation openings in square millimeters. So you can see here, some say 2,000. Now this is your climate zone. So if it's a climate zone A, and there's no membrane on the ground, then we need 2,000 square millimeters of ventage basically for every meter around the wall. So what we would do is basically come back to here and find one of these that is actually 2,000 square millimeters, and then we would satisfy that by putting one of those every meter around the building. So where it gets a little bit confusing for some people is this tells us how many square millimeters the actual vent opening is, but when we actually place it, it's per like linear meter. So when we look at this other diagram, I'll just bring it back up. Oh, sorry. Oh, hang on, it didn't open for me. Sorry, 1 second. I actually can't find that thing that I had opened up. So at the top here, when it shows us this, so I said it's every linear meter. So linear meter is actually a length, it's not square meters. So it tells us for every meter we come across, that's how many square millimeters our vent needs to be, is this one here. So when we come back to this one here, we work out, okay, is it climate zone A, B, or C? And then is the subfloor, has it got a membrane over it? Or, so no membrane, or is the ground sealed with an impervious membrane? And then we basically just line up the tables and go, okay, climate zone B, there's no membrane, therefore it's 4,000 square millimeters. And then when we pick our vent, we come down here and actually pick which vent would actually, because we can see this one here wouldn't work because it's only 3,840. We would need something that was 4,000. So we can use these other ones that are 4,000. And then what it actually tells us is this is what our spacing is. So if you wanted to, even though it says that they've got to be, when I come up here, basically every meter, it tells us that in our building code. This actually tells us how often we would need to space them to actually achieve it. So this one here, if we wanted to achieve 4, because obviously bricks aren't going to fit exactly when we put all the bricks in to be exactly 1 meter. So if we wanted to achieve something that had 48,000 millimeters, we would have to space that basically every 800 millimeters, and that would then achieve the requirements for the 6,000 square millimeters. So I hope I haven't confused you, but you could use that vent there to achieve a 6,000 square millimeter by just placing it every 800 millimeters instead of placing it every meter. So this tells us if we want to meet the requirements in the table here of climate zone C with no membrane, we can actually use those other vents. We just need to space them more often than every metre. So that's what that one there tells us. So we could space it at 800 millimetres. This one here, even though it's only 3,840, we could space it at every 640 millimetres. And therefore we would be achieving this table here that's actually in our building code. So it's really up to you, how it's done. It's probably going to be designed in our plans anyway. But yeah, so that's just another way you can get around it. If you can't actually get it to space every metre, you just look at that table and it tells you. So the easiest way, when we're going to do exercise later on, is probably just find something that's if we have to find 6,000 square millimetres, just find something. It might be one of these ones here, one of these Prida ones, and then if you put it every metre, then you're going to actually basically be okay, because this one here, it tells us every 1,049 meets our requirements. So that's a little bit of a background on basically what our subfloor is. And you'll see there's another part in our building code, and I'll just bring it back up. So this section here, guys, is just the section which is subfloor ventilation. So for those guys who actually haven't done this part of the course before, and you're wondering, hey Adam, where you're finding this information, basically if you go to the building code, and we pretty much only ever deal with section 3. So there's section 1, which, basically it's sort of where we would go to find out all our definitions and so on. Section 2 of the building code talks about, sort of how something has to perform, the performance requirements, and then the objective of putting that in. And then section 3 is the stuff we'll be using throughout basically this course, and also when you're going for your testing, because it's what they call acceptable construction. So I always say, at the end of the day, we're not too concerned with when someone goes and designs a product, what do they do to make sure it's compliant? Because that's what the first sort of parts of the building code tell them what they've got to follow. We're more concerned about, because we're the guys who are constructing, hey, look, I know this product is actually available, and I know it meets the requirements. How do I build it so it's going to be compliant with our building code? And that's why we go to section 3. And section 3 is called acceptable construction, and it shows us how to basically build something so it is compliant. So this is just an extract, which is part 3.4.1 from the building code, which is all about subfloor ventilation. So if you guys, were in your testing and you're looking for something that we hadn't covered or highlighted, you would just basically go to your building code, and if you're not familiar with it yet, you'll just open up to your contents, and you'll come down, and basically when it gets to section 3, acceptable construction, it's broken down in pretty much the way we would build a house. 3.1 is site preparation, 3.2 is footings and slabs, 3.3 is masonry, 3.4 is framing, and basically so on. It goes into our glazing and our fire safety and other parts. So if you do get stuck and you go, geez, I haven't done that before, just go through your headings and I'm sure you'll be able to find it. So that's what that subfloor ventilation is. And when we come down here, it talks about what's a table I just spoke about with our vents and how big they've got to be. And then we'll see other stuff where it talks about the climate zones. And you can actually, if you need to find, so it shows a bit of a map here where it talks about zone A. So this is zone A in the middle, which is our sort of central Australia, I suppose. Zone B, you can see, is on the outside here. And then zone B is in the middle, and zone C is the one which is on the outside. So you can see pretty much goes from our Melbourne down to Tassie. And that's where you can also go to the beginning of the building code, and under our definitions part, or what they call interpretation, is actually, there's a part in there that says climate zone, and it breaks that down even further so you can figure out climate zone 1 through to 7. But as far as what we're talking about here, we're talking about ventilation. Basically, we're zone C down here, and this just talks about it, what I've sort of spoken about previously, about how often they've got to be placed with our vents and so on. And then the other stuff, this is another diagram showing where those vents go through our masonry. So I tried to show that other one before. This is just another take on it. And your engaged pier, if there was one to be back here somewhere so that vent didn't flow into the engaged pier. and then it shows us what our minimum actual requirements are. So when you read through that, I'll let you guys read through that when you're doing your questions a little bit later on, but that's got to do with basically being able to inspect if there's any termites and so on underneath, and there's minimum height requirements which are just there. So we'll draw those in a little bit later on. And there's basically one there showing one that's on a clad frame rather than actually being our masonry up the outside. So you'll see the measurements are pretty much the same. So what I thought we'd do from there, guys, is I thought we might start our first exercise, and you guys have a bit of a crack at it, and I'll just bring it up. And this was one that the VBA were asking, I don't know, maybe 6 months ago, and so I'm sure it'll come back in vogue one day. So we still want to understand this one. So have a crack at it. If anyone actually hasn't got this, let me know. I'll email it over. And for those guys who have done this one, maybe just for yourself, because it does want us to work out what our footing depth is and the reinforcement that goes on it. So let's have a look and see what it tells us that it is. Actually, it doesn't tell us there, does it? It's normally written there somewhere. Oh yeah, sorry, S-class soil. So that's it. So maybe the guys who have done it before, why don't we do an M-class, and then you guys can just work out. Oh, you haven't done it, Tom? Cool. No worries. Also, do you actually have a copy of that, Tom, or you want me to email that over to you? You'll check. Okay, cool. We'll just, so if you haven't done it, guys, let's do it as it says there. So it talks about its S-class soil. So we're going to go, where is the correct position of the subfloor vent? So have a look at that and see, which brick you would take out and put the subfloor in. Then what the reinforcements are required for our strip footing. And then we'll obviously draw that in. So work out what size our reinforcing needs to be, draw it in. Then we'll talk about what is the minimum clearance under the floor for the sloping ground in a termite area. Then we'll go to what is the minimum ceiling height in a bathroom. With these waterproofing ones, guys, have a crack at them. And if you don't know it, that's fine, because we're going to do waterproofing in the coming weeks. So, but you'll be able to find that in your building code anyway when you look under. Cool, Tom. When you actually look in your building code, you'll be able to find that in waterproofing. But if you can't get those answers yet, don't stress, because we'll actually do waterproofing in the coming weeks. And then we'll work out what the ventilation is, what the minimum height of the tile above the laundry trough is, so that'll be in waterproofing as well. The height of the flashing required up the frame for the weatherboards. Another thing there too, if you haven't done that one, don't stress. That's something that we teach in the coming weeks when we do our masonry as well. And then also the fixing requirements for the weatherboard. So it'll mean have a crack at those and see how you go. But some stuff there, and it's pretty much from number probably 6 down, we actually haven't covered. So have a crack at it. If you can't find it, don't stress, because we're doing it in the coming weeks anyway. So yeah, the guys who've already done it, do it on a class M. And yeah, when you're done, just type in the box done, and then we can basically, I'll put up the answers and we can compare them and see how you went with it. And any questions in the meantime, yeah, just either speak out to me, I've got you all off mute, or just type it in the box. And if you're wondering when it comes to the ceiling height, guys, I'll just tell you, that's probably one of the things that we don't sort of cover too much about. But if you're wondering when you're looking inside your building code for it, if you look under health and amenity, and then you'll see there's actually one of the chapters in there that says room heights. You'll go in there and it'll tell you the heights of the different rooms. So you have a crack at that, and when you get stuck, just give me a buzz. And later on too, guys, in case I forget, can you guys remind me later on, and I'll tell you a bit of feedback from one of the guys who went and did his test basically last week, and I'll tell you what he was actually asked to draw when it came to a raft slab. So hopefully we'll get that done, something that we can email out, but I don't want to forget that tonight, because I know there's some guys going in the next couple of days. Yep, cool, Valavan. I'll send that over, mate.
Adam, was this the written test or a
It was for the drawing,
review?
so it was the raft slab, and they've got like a little bay window in it, and it'll be easy for me to actually show you when I put it on there. I've got a little bit
Okay.
of a picture, and then I'll bring something up on the standards. Yeah, so it was more it was the drawings. Everyone seems to be breezing through the multiple choice. The guys that I've been speaking to who've got their results have all been getting above 90% in their written questions, but they've in the multiple choice, I should say. But a lot of them have actually been finding it hard to get through all the content of the fault finding and drawing the plans. So, I'll give you something here which will hopefully give you a bit of a heads up on it.
Yeah, because I did my exam on Friday myself. So
Oh, cool. I knew it was soon. Yeah, I thought it was this Friday.
no, it was last
Okay.
Friday
Oh,
past.
cool. And how'd it go, Greg? Did you think you went well?
Oh, I have no idea, to be honest with you.
Okay.
I thought it was interesting that there was a lot of questions on the exam. I would have kind of challenged what you just said in the sense of there was a lot of questions on there that I'd never really seen before, for me
Okay.
anyways.
Yep.
Uh, Not that I felt like I had necessarily problems with them,
Yep.
but there was a lot of questions that, I guess I expected it to be a lot more autopilot than it actually was.
Yep. Okay.
Uh, at the same time, there was a lot of questions. I actually had to challenge the examiner like 3 times. I'm like,
Yeah.
well,
Okay.
you haven't given me enough detail to answer this question,
Yep.
which really surprised me. I actually walked out of the exam thinking to myself, if I fail, I'm going to challenge them, because I was surprised at how many questions they asked that really were wrong.
Yeah.
Like
Yep.
they asked about security of payments as one question, how many days if you don't have an agreement. And the only answers they gave you was 14 days, and then a couple other that you knew were wrong.
Yep.
But of course, in the Security Act, it's 10 working days.
Yeah. Yeah.
Where
Exactly.
they went 14 days.
Yep.
And it's like, well, that's not right, because if I invoiced on
Yeah. On a Monday, it
April
could be 12.
20th,
Yeah.
well, yeah, but April 20th just passed, or
Yeah.
was the 13th just passed.
Yep.
With Good Friday, Easter Monday.
Yep.
So I mean, the questions they're asking, like, it's a wrong question. You
Yeah.
can't ask that question.
Yeah. Yeah.
They're trying
Exactly.
to trick you. They're
Yeah.
tricking themselves.
Yeah.
And they asked me to draw steel in for like we're doing right now for the garage. That was an infill slab on a class, what was it, class M, I think it was just a class M site. And I'm like, well, you actually can't put an infill slab on a class M site, so why are you asking me to
Yeah. It's only A&S
put
from
in?
memory, isn't it?
Yeah, exactly,
Yeah.
only A&S. So
Yep.
and they're, oh, don't worry about it. I'm kind of like, well, hang on here. You're telling me you're going to decide whether I get my builder's license or not, and you're asking me questions like this?
Yeah. Asked me to design stuff that can't be done.
Yeah, I'm like, hang on here. So anyways, if I pass, whatever, I don't care.
Yeah.
But I would, if everyone that's listening, just be mindful, not to worry, but just be mindful that they, pay attention, really, I guess, more than anything.
Yeah. Yeah. Okay.
But anyways, that's
Okay.
my
Yeah.
feedback.
Yeah,
I didn't get the.
and you'll actually be a good one when I bring it up about the raft slab. So did yours have like a little bay window, like a little step out on it?
No, I didn't notice that.
Oh, you
So
didn't? Okay,
maybe,
no. Okay.
I didn't find the raft slab drawing the beams that hard, other than I almost forgot about running all the beams off the internal corners. But
Yeah,
I
okay.
realized, but it didn't seem. It was the roof that threw me off.
Yeah, okay.
I still don't know how you're supposed to tie together the roof with the garage in the front of the house. But anyways.
Okay. I'll have to, yeah.
But yeah, we'll look at the drawing and I'll see if it's the same one that I got or
Yeah.
not.
Oh, I haven't actually got it. The guy just did a little sketch for me, and then he went, "Nah, that's not right." He said he actually came out not being. He said, "I don't know how people can come out and actually give you such a detail." He said he came out a bit flustered, going, "Wow, I can't." That was just 2 hours. It felt like it went for 5 minutes, and he was
Oh
sort of
yeah.
yeah, he was a bit sort of mind blown, going, "Geez, what did I actually do there?" And he couldn't. He just remembered. Yeah, basically, he thought that he'd done it wrong, and yeah, was able to say, "This is where I think I went wrong." And he sort of just showed me a little bit, and I'll show a diagram that looks similar to what he was telling me about. So I'll bring that up shortly.
Yeah. Yeah, but I agree. I think everybody, there was like 20 people there. Everyone kind of walked out like, and this is a Canadian thing, but we all walked out like deer and the old headlights, you just kind of were like, or I guess you could say a kangaroo in the headlights, a wombat in the headlights or something. You're frozen. I think, as I said, everything made sense, but you were just like, holy shit, the pace of this thing, you've got to go, 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 go. You know, you
Yeah.
can't muck around.
Yeah, exactly. Like, what time was your actual testing?
It was 11:30 on Friday.
Okay. Yeah, no, because I've had two of the guys that I've trained in face-to-face classes. One went in at 11:30, and the other one went in at 2, I think. And and they both felt they went well. The same thing. I thought, geez, that was pretty hard to get it all done, but both came out reasonably confident that they'd actually done enough to pass.
Yeah, I would be surprised I failed, but I really don't know.
Yeah. Now, and here's another thing too, which I was surprised. One of the guys I've trained face to face, he came out devastated, thinking that he'd messed it up, and they told him that he passed and invited him back for his interview. And when he actually got his results, he actually only got 67% in the plan drawing, where you meant to get 70%. So he got 90-something% in the multiple choice, but only 67% in the other one. And so you meant to get 70, and they passed him. So admittedly, he said that he didn't get it all done, so he thought that maybe because what he did complete, he would have got a pretty high percentage of it being right. If he's only finished 80% of all the work and was still able to get 67%, he's running, if they weren't okay, well, if he would have been able to finish it, he probably would have got another 3%, so let's bring him in. But that's the first time I've heard of that. Normally, if you don't get 70, it's like, sorry, mate, you got to come back. So that's probably
Yeah.
a good thing as well. Cool. All
Yeah.
right. Thanks, Tom. Thanks, Dean. I'll just wait till the other couple basically finish it off. Sorry, guys. I just change that for a second. Yeah, I just noticed one of the guys, might have been Valavan, emailed or typed in the box saying that the version that that I had up had 8 questions on it, but his had 10 questions, but his copy in his book only had 8. And yeah, I was wondering why I had actually 2 copies on my USB drive here. So the one with the 10 questions, that was an updated one that the VBA were doing towards the end of last year. So this is probably the one that you've got inside your book. So if that's the one you've got inside your book, the drawing and everything's still the same. There was just basically an extra 2 questions relating to some of the stuff in there. So yeah, if you're wondering why that happened. All right, so I think that might be most of the guys done by the look of it. If you're still going, just type in there, hey, can you give me another couple of minutes? Because once people start typing in, I can only see about 5 replies at a time. I think I've got that are done. Yeah, it looks like they're all done. All right, cool. So I'll bring this up and we'll go through the answers. All right, so this is for the Class S. So as you can see, from what we would have done in our last class with our strip footing, so basically our top and bottom for our trench mesh. So I might just make that fractionally smaller. So, and we'll get to those in a second because the answers are down here. So basically, as far as where the location of the subfloor vent, so it's in position C, because as we would have seen, it needs to be under our lowest bearing member. If we had it up here, it'd just be blowing straight into our bearer and or straight into our joist. So it's got to be position C, and that's where our vent would go. So the reinforcement for the strip footing above, basically we look in our masonry veneer 3L8TM top and bottom. So that's what that there is. Show the location of the reinforcement, or we can see it there in the drawing. Then it says what is the minimum clearance under floor to sloping ground in a termite area. So I don't know if they've drawn that on there, but if we look at, let me bring up the one second, I'll bring up the building code for us and we should be able to get it out of there. So there's one there, yep, shows us basically 150 to 400, and that's, it'll be the same, that's with a clad frame, and our other one there, it's still the same thing, so it's still 150 to 400, and that 400 actually has to be basically no further back than our 2 meters. Because that's obviously, if you read the building code, I can't remember the exact wording, but basically you need to be able to inspect for termites. And I presume that if you're any further back than 2 meters, then they must deem that's too far away to see if we've got any, pest management issues. All right. So the next question, what is the minimum ceiling height to a bathroom? So that's basically 2.1 meters. So if we looked in our building code, as I told you before, if we look under the health and amenity section, and then in there's a little chapter that says room heights, and if you read through your room heights, it talks about, hallways, non-habitable rooms, kitchens and bedrooms and living areas and so on. It gives us our height. So that was 2100. And with these ones here, this is our waterproofing then. So what is the waterproofing requirements for the bathroom floor? So there is actually a table within our building code, and there's also one in obviously the Australian standards for waterproofing. And just basically, because we've got a timber floor, you can see here that it's timber. I suppose it doesn't really tell you that it's timber, but obviously it does say in there that if it's a timber floor, then you've got to waterproof the whole floor. And we'll cover a lot more in waterproofing later on, so don't stress too much about those ones if you couldn't find them. Basically, the minimum ventilation is down here. So that was at 6,000 square meters. So that's when we look at, let me find it. This one here. Oh, sorry, gone the wrong one. Sorry guys, bear with me a second. That's what happens, I've got so many bloody tabs open. When we went into here, into our climate zone C, basically we just lined up the dots. So climate zone, it's a highlighted one there. So climate zone C, and there was no membrane in that drawing, so therefore it was 6,000 square millimeters. That's how big our vents needed to be. All right, so then what is the minimum height of the tile above the laundry trough? So that's 150 millimeters. Same thing again, we'll cover those in more detail later on. These are just ones that are added in to sort of suit that drawing because what the VBA were doing. With the height basically of the flashing returned up the frame for weatherboards. That was in there of our 25 millimeters, and we'll cover that in more detail later on as well. And then number 10, the fixing requirements for weatherboards. If we look in our building code, I can't remember the exact size of the nail, but when they go in through a weatherboard, basically they're not meant to actually pick up the 2 weatherboards. You should be nailing it basically towards the bottom of the board, and it's got to be high enough up that it actually doesn't pick up the board underneath that it's lapped over. There's a picture in there that shows that. And I couldn't remember off the top of my head exactly what it is. I got a feeling somewhere between 25 and 30 mil, but it will obviously determine basically how much that actually weatherboard laps, and then it talks about how much it's got to penetrate. So, but we'll be covering those in the coming weeks anyway. So that was pretty much the answers for those. But the main part we want to be concerned with was just really the ventilation, the subfloor, basically heights. Yeah, 1 second, Valvan, I'll do that one for sure. Was our heights, and then our strip footing. So just got a question here about question 2 and question 3. So question 2 was about our reinforcing required for our strip footing. So what we would do is, 1 second, and I'll just grab out my Australian, actually I haven't got my Australian standard on me for basically the slab for our slabs and footings. It's probably in our building code, so give me a second and I'll find it. I suppose that was probably one that was a bit dicky as well, because it's a double drawing. One side's got a clad frame and the other one's got it going all the way up. But I think we went on a masonry veneer. So 1 second, mate, I'll just find it in my building code.
I came across an interesting thing too, Adam, about the concrete cover for strip footing in AS 2870 towards the back.
Yep.
It has some trench details and it shows the minimum cover is 50 mil.
Does it in, so it's that in your standard, does it, or in the building code?
2870.
Yeah, okay, in the standard, okay. And it says, what, it says 50 mil, does it?
Yeah, it says requirements. So it's section C5 detailing requirements. So this is towards the end of the book.
Yep.
And it has requirements for rafts and slabs. And it's showing a sectional of a strip footing, and it's showing 50 mil.
Okay, it's funny because it says somewhere from memory when it talks, unless it's about a different slab, I just remember seeing something in there where it talks about if it's, protected or unprotected, and I thought that if it was protected it was 40 mil. But that's going from memory without actually having the book in front of me.
Yep, no, you're right. It's exactly that. But as I said, I just stumbled across it.
Yeah.
When I was studying, and that really threw me off because actually, ironically, that was one of the questions I had to answer too.
Was
I'm like, what answer do I go with? Because I think they're both kind of right, but
yeah,
I went with the one that we've been talking about. So 40 mil, but it was just interesting to see that detail, because you don't see the detail in the actual strip footing section earlier in the book.
Okay. Yeah, I haven't got it in front of me. I'll check it out later on when I get offline, because I've just got my book set up and I just send it out. Yeah, for sure. Yeah. All right, cool. So just got a question from Valavan just to ask if I could go over that. So I've just Valavan, I normally use my Australian Standard 2870, but it also is in the building code. So when you go to strip footings, there's basically a table there, and it talks about how deep this footing here needs to be. Basically how wide it needs to be, and then the reinforcing. So what we would do is we go and go, okay, the first we need to determine is, first of all, it's a strip footing, so that we don't go to our raft slab or to our waffle raft. So it's a strip footing, and it says it's an S-class soil. So I'm going to go to my S-class soil for strip footing, and then it asks me for the type of construction. And my options are a clad frame, articulated masonry veneer or masonry veneer, full masonry, and articulated full masonry. So it probably doesn't give us too much information. It's hard because one of these is a clad and one is actually masonry, and it doesn't state whether it's articulated or not. But when we look at our table, it doesn't actually change for any of those anyway. So it tells us that the depth should be 400 millimeters deep. It should be 300 millimeters wide, and then the reinforcing to go in that should be what they've got here, which is our 3L8 trench mesh in the top and the bottom, which is how it's shown there. And then when it says show the location of the reinforcing, whenever you look at any of the pictures, when it talks about our strip footings, you'll always see that they've got top and bottom in it. So that's why we just draw them in exactly how they are in the actual building code or in your Australian Standard 2870. So yeah, if you need a bit more assistance on that, let me know. And when I have our break, I'll go and grab my standards out of the car, because it was just something I had in there for tomorrow with the class that I'm doing, so I wouldn't forget to take it. So yeah, if that didn't make sense, let me know and we can cover that in more depth later on. All right, so I'll close that one there down, guys. Okay, so from there, guys, the thing that I wanted to talk about from here is tonight we're going to be actually, no, we'll do that later. So I was going to talk about that thing than the plans the guys told me, but I'll wait till I've got my 2870 in front of me and we can talk about it after the break. So yeah, what we're going to be doing, guys, is actually designing a subfloor. So I thought the first exercise that we would do, this is one that I made up today, and it's just drawn with a ruler. So don't, I'll just bring it over onto the screen. And I think this is probably a good one to start with as well. And oh, how good's that going to be? And then the guys who actually haven't done this before, too small. I'm getting there, guys. Give me a second. Too big. A bit like Goldilocks, isn't it? There we go. So what I've done here is just a drawing. I just sort of make it pretty simple, and we'll make that it's 13 meters long, 8 meters wide. And the scenario I wanted is that it's single story. It's got external load-bearing walls. It's got a clad frame, a truss roof. So obviously there'll be no internal load-bearing walls. It's a sheet roof. We're going to use continuous span bearers, and our joist spacing is going to be 450 millimeter centers using F17. So we want to work out the computations for the bearers and the joists, and basically the footing type. So we need to know, to do all of that, we need to work out what our bearer spacing and our bearer span is, how many rows of bearers we obviously need, and then we work out how many stumps we need. That'll determine what our bearer span is as well. So what I'll do, I'll bring something up basically out of the building code just to determine, so you guys can figure out, if you're not too sure, what the actual difference is between spacing and span. So it's probably easier if I put a diagram up. Just bear with me a second, I'll open up my building code. All right, so I'll just find it over here. Give me a second and I'll find it. I think it's in framing, so bear with me a second and I'll just find, here we go. Let's close that down, make this a bit bigger for you. Right, so this here, guys, is basically showing us, and this is across different parts of building that we use, but this is showing basically our subfloor. So these would be our bearers, and when we're talking about spacing, spacing is actually the center of one member to another. So if you can imagine, these have probably got some posts underneath them, and so these are running back away from us. So when we look at the picture that I had up before, we would have, you can see my mouse, our bearers run long ways through the house. So basically if we've got one here on the edge and then one in, say, 1500 millimeters, our spacing is actually from center to center. So just trying not to get the terminology mixed up. So spacing is from center to center, and then our span is actually where it's supported. So if we're looking at this joist on top, basically the joist, the span, is from the inside of that bearer to the inside of that bearer. So that's the difference between span and spacing. So with our bearers, we're actually going to have span and spacing on our bearers, because when our bearers run this way, and we'd say we've got one run there, if you can see my mouse, and then another one, how far they are apart, the two separate bearers from center to center, is actually the spacing. But where they're sitting on the stumps is actually then going to be the span of that bearer. So you will have this in your, I'll bring this one up as well, you'll have this in your booklet. So when we look at this here, when I say in your booklet, in your study buddy folder that you got from builder registration. So this is a good diagram of that. So this is showing basically the way that bearer is now going long ways. So the span of that bearer is actually from the inside of that post to the inside of that post. But when we look at our building code, when they're going in the opposite direction, then our spacing is from center to center. So that's why we need to actually know basically the difference the two when we're actually reading our tables. And then another thing they talk about is continuous span. So with that that joist sitting on there, it's called a continuous span. It says members which are continuous over two or more spans. So because that's basically spanning across one member and then across two, basically that becomes then a continuous span, where if it was just joined where these lines are here, it would then be a single span. So when we're going to work out our bearer spans later on, there'll be two tables, one for basically single spans and one's for continuous span. And they've all, depends on what the scenario is, but obviously it's a lot less labor intensive. If we're running a bearer and we can get something that's 4.8 meters, it means that we don't actually then have to cut it every 1500 millimeters to fit on our stumps. So that's why then it becomes a continuous span. And it's you'll find that it'll span further as a continuous span rather than a single one anyway. So what I thought we'd do, I thought the guys who actually know how to do this, by all means, just go ahead and do it, and I'll leave it up. And I thought for the guys who have actually never done this before, I might step you through how we would do this, and then you can tackle the one in the builder registration folder on your own. So now, if you have done this before, guys, there's lots of different ways to actually do it. I'm going to teach you the way that I do it. I actually like to work out the subfloor, and once I've worked out basically where my bearers are spaced, where my stumps are going to be, then I actually work out the footing size. And some guys do the opposite. They work out what footing size they want and then get a bearer to match it. So there's no issue with doing that, because what happens is, if we look at that picture I had there before, and I'll show you this later when we go to our Australian standards. So with our footing types, we've got footing type 1, 2, 3, 4, and 5, and actually what makes them different is the size of the concrete in the ground. So this one here is a footing type 2, and you can see that it needs to be a 350 millimeter diameter and then 150 millimeters high of concrete. Whereas when we look at footing type 3, then it says here that it's 200 millimeters high with concrete and 400 millimeter diameter. So what happens is you can go and get a bearer, and I'm making these figures up so don't quote me on them, and you might get a bearer that spans 3.3 meters. But when you actually look at these footings, because the footing is so small, it won't let you span anything bigger than 1700. So just be wary of that. We need to make sure that when we choose our bearer, that we see what our spans are going to be, that our footing is actually strong enough to cope with the bearer spanning that far. So that's why I normally design my subfloor first, then I know how far my bearer has to span and go, yep, okay, that bearer is spanning 1700 millimeters, therefore I need a footing type 2 or a footing type 3, and I just basically match the footing to it. So if you do it the other way, that's great. I just thought I'd clarify that before we actually cleared it up, before we actually did it. So I'll take you through this first one. I actually find this is, I think, probably the hardest thing in the course if you haven't done subfloors before. So if you don't get it, don't stress. And there are some exercises online as well, which we've got. But yeah, more than happy to send, if you guys go at the end of it, hey Adam, I didn't quite grasp that, let me know and I'll do up some other drawings like this and send them over. So, all right, so the way that I work it out, when we actually look in our Australian standards in the table in the back, when we're working out our spans and how far they'll go, we can get stuff that spans pretty far distances, but good practice is to try and keep them no further than 1500 millimeters apart. That's just sort of what we do within industry. It sort of stops a lot of springiness in the floor, and it's just sort of best practice, I suppose. So when I'm working this out, I said the bearers are going to run long ways. So the first thing I do is work out, okay, Adam, how many rows of bearers do I need? So what I'm going to do, I'll just bring up my calculator, and I might actually put it on the screen so that you guys can see it as well. Hopefully this comes across. Yep. So that's my calculator. I'll make it a little bit bigger. Right, so the first thing I do, because the bearer is going to run long ways, I work out, okay, how many actual rows of bearers do I need? So what I'm going to do, because I know it's 8,000 millimeters wide, I'm going to go 8,000. You can work in meters if you like. I like to work in millimeters, divided by 1,500, because I said we always, best practice is to try and keep it at 1,500. All right, so it says there basically 5.3.3.3. So you can actually round it up or you can round it down. What would happen though, if I rounded it down, then the spacing would be bigger than 1,500. I'm probably going to get something around about 1,600, which isn't the end of the world, but just for, I think, ease of using these tables and when you go to the VBA, I just try and keep it under 1,500, and I'll show you how that works later on because it always works in with the footing type that I like to choose. So I'm going to round that up to 6. So just be aware when the calculator works that out though, that actually doesn't give us this first bearer, because when basically we work out how many we need, when we divide it by, well, actually what I'll do, I'm going to round that up to 6. So I'm now going to go, I'll work out what my spacing is. So I'm going to go 8,000 divided by 6. And it tells me that I'm going to space my bearers at basically 1,333 millimeters. But the way that calculator works it out, if we start here, it goes, yep, I need one at roughly 1.3, then 1.3 again, and all the way down till we get those 6, but it never gives us the one at 0. So when I said that we needed, when I did 8,000 divided by, I'll do it again, so when I went 8,000 divided by 1,500 equals, and I went, yep, okay, well, I'm going to round that up to 6. I need to add one more to close it off because it's actually telling us there's 6 spaces at that 1,333 millimeters. So when you round it up, you always add the 1, or otherwise you're not going to have the 1 where you started because it doesn't give you the 1 on 0, if that makes sense. So by rounding that up, it gives me 6, and I add the 1. So I know that I need 7 rows of bearers. So basically 1 through there, and then I would divide them up into that 1,333 or whatever it was. So I've worked out basically I need 7 rows of bearers. So the next thing I'm going to work out is basically I'll bring up my Australian standard and we'll work out the size that we actually need. So one second, I'll bring up my Australian standard. Just let me, so in basically this will be probably the first time we've used our 1684, and I'll go through in detail in it later tonight and also next week. I'll just get us to the page first. Towards the back, there's actually our, here we are, our span tables. And this is how we start to work out the different sizes of timbers that we need. And so if you haven't tabbed this, guys, definitely chuck a tab on it. So where's the, this is it here, and it tells, I'll make that fractionally bigger. So this is our span tables list. So we need to work it out what it is we're actually basically trying to do the computations on. So I've just got a tab on mine, and I've just gone basically span tables. So then when I know I'm asked to basically do up some computations, I can go to this page and then figure out, okay, am I doing bearers, am I doing joists, am I doing studs or whatever. So if I come back to my scenario of what we're working out, we're doing a single story external load bearing walls. It's a clad frame, truss roof, and it's got basically corrugated iron on it, and we're using continuous span. So I'll come back to my table, and we're doing a bearer obviously. So I'm gonna go bearers. It should be table A4. So it's a bearer supporting a single story external load bearing wall with a sheet roof with a continuous span. So it's table A4. So I'm gonna come down till I get to table A4. Oh, this is table A4. And when it says it's a strutted roof, so basically a strutted roof, guys, is when it's going to be an old style pitch roof, conventional roof, and it's actually got the supporting timbers basically that'll go down onto our load bearing wall. So basically ours isn't a strutted roof because I've said that it's going to be a truss roof. So come down here, this is an unstrutted roof with a maximum rafter span, or a truss, we said it was truss roof, of 6 meters. So if I come back to my drawing, because it's 8 meters wide, we'll say our trusses are spanning this way. So our truss span is actually going to be 8 meters. So let me bring this up again. So I need to go to the next table because this table here uses truss roofs with the span of the truss being 9 meters. All right, so this is basically the table we need to be in. So when we come here, we've worked out that our bearer spacing was 1,333 millimeters. So we're going to be using this table here. But as you can see, the next thing what we need to work out is what is my bearer span. So when we look basically at these pictures, this one here, our bearer span is basically how often are these stumps spaced so that, you know, that they're supported on these stumps. So I do exactly the same thing again, is I try and space these at 1,500. So the length of that wall is 13 meters long. So if I bring up my calculator, I'm going to go 13 meters, or 13,000, oh, not that big. Can I go back on that? No, I'll just clear it. So basically our 13 meters or 13,000 millimeters, I'm going to divide that by 1,500 because I want to try and keep everything at 1,500 so the floor doesn't bounce, and it's just the way that we do it on site. So we're going to divide that by 1,500. And that's going to equal basically 8.666. So remember, I'm going to round that up because if I round it down, my spacing is going to creep above that 1,500, which isn't an issue. It's not a huge issue. Just for the footing type I like to use, if I keep it under 1,500, I can nearly always use the same footing type. So I'm going to round that up to 9, and just remember I have to add 1 on because it doesn't give me the 1 at the beginning. So therefore, once I round it up to 9 and add 1, it means 10. So I'm going to have 10 stumps all along here. So then if I go 13 meters divided by my, oh sorry, I messed that up. Sorry guys, let me do that again. I should have been writing these down, I'm going from memory. So if we go 1300, that's our divided by our 1500. So I said, what do you do? So we rounded it up to 9. So that means I've got 9 spaces, but actually 10 stumps. So what I'm going to do to work out my spacing is go 13 meters divided by my 9. And you can see there that my spacing of my stumps is actually 1,444 millimeters. So just remember that that's giving me from the center of the stump to the stump. And we don't have to get too technical, but just so if you're wondering, so that's giving me from center to center. So if we've obviously got a stump, we're going to pick up a couple of mil anyway, because if it's a 100 mil stump, well 50 mil either side, and then my spacing comes down a little bit more. But what I'm trying to get at is we can see already that it's going to be no bigger than 1500. So when I come back to my table in the Australian standards, I know now that I'm using the bearer spacing, so how far apart they are spaced to give me the amount of rows was less than 1500. Then my bearer span, so how often are these actually bearers supported on a stump? It's going to be less than 1500. It'll be more than 1200 because I'm only picking up roughly 100 millimeters. So I then come across and I said we're going to use F17. So my bearers are going to be 290 by 35. So that's basically the bearers, that's the size bearer that I need to use to basically be strong enough to support that structure. So that's how we would work out basically the bearers. So if I come back, I didn't actually have time to draw this in today because I was out. So if you can see my mouse, we're going to have basically the amount of rows of bearers. I think we said it was going to be 7. Correct me if I'm wrong. I've probably written it down somewhere, but yeah, so we have them running along there. Then we'd have every 1400 millimeters they would be spaced. And now we've worked out our stumps, we've worked out the size bearer that we need, and then we need to then work out basically what our joists are. So if we were to come back to our Australian standard, and I'll go back to the beginning of that table, and now we're going to actually work out basically our joists. So when I come down here, you'll see in here floor joist supporting floor loads only, and that's what we're going to be used. Even though the end of the joist will actually have load bearing on it, that'll be transferred down into our bearers anyway, and I'll show you how that works a little bit later on when we get floor joists that actually are supporting our roof loads. But because there's no internal load bearing walls, these joists are only going to be supporting floor loads anyway. So if I go to that table there, which is A8, I'll just make this a bit quicker. A8, so this is where we are. Our floor joist supporting floor loads only. I did have written in the scenario that the joists were going to be 450 millimeters. So you can see here single span and continuous span. So they're going to be continuous. I'm not going to bother cutting them every time they land on a joist, or every time they land on a bearer, sorry. So from memory, our bearers aren't going to be any further than, because that's where they'll be spanned on, because the joist sits on top of the bearer. It's going to be using this one here. So we've got their 450 centers, and basically it was 1400 and something the spacing. So it was bigger than 1200 anyway. So we use this one here. We bring it across to the table, F17 timber. We can use 70 because that lines up. Oh, it's not going to work for me that way. But basically that one there lines up with our F17, and it lines up with the 15 millimeter joist span, and also for our spacing though, because they were no further than 450 millimeters apart. So the size of our joist is 70 by 35. So that's pretty much how you would work out your sizes. And then the last part of the scenario, guys, is actually working out that footing type. So I'll come back to, and we'll highlight all this stuff a little bit later on. I just wanted to actually show that one there. So this looks like, this is it here. So in the Australian standard 2870, and where we're going to be, so this is the bearer spans. So when I was showing you that other picture before, and we spoke about, basically how far these bearers could span, even though we went to the standards and we could have got stuff that spanned 3 meters, as I said, a lot of it's determined by what your footing type's going to be. So when we come back in here, this talks about our footing types. So if we look at our scenario, we've said that, our bearer spacing is not bigger than 1,500 millimeters. This is why I like to keep it under 1,500 millimeters. So if I go, yep, well, my bearer spacing was no bigger than 1,500 millimeters, and the truss span, it was 8 meters, but it wasn't, so we use this 9 one here. It wasn't bigger than 9. So we can use that one there, and then we come down, and this is then what our bearer span was. So the same thing again, I kept the bearer span at just under 1,500. So what I'm going to do is go, yep, I'm using a sheet roof, which is this one here. I'm using a sheet roof. My truss span is just under 9 because it's an 8 meter truss. And then I just come down here and actually find, I can't use, this says, okay, what bearer span have you got? So how often is that bearer supported? If it's less than a meter, you can use this one here. If it's less than 1900, you can use this one here. So that's why I'm going to use, mine was 1444, whatever it was, which is that basically fits this 1900. So I come across, I can actually use a footing type 2. So that's the last piece of the puzzle. So some guys like to use that part first, but I like to just basically set it all out and then come down and basically line up these numbers to actually give me what footing type that I need. So if you're wondering what the footing types are, I said it shows it's here, it's illustrated there, but we'll highlight it. That gives you like a visual of it. But when we look in our Australian Standard, just let me find it. This is talks about our footing types here. So here we go, sorry. So this is the footing. So if we're using a footing type 1, it talks about the bearing area that it needs to be. And then also this is basically the size that it needs to be. So the minimum size of an unreinforced concrete pad footing is 230 millimeters by 230 by 100 millimeters deep. So that's if it's square. And obviously if it's round, it's 250 diameter by 100 millimeters deep. So that tells us there basically what size those footings need to be. So that, as I was saying, when I went to here, and so if we were doing this for real, and I said, yep, I'm going to use a footing type 2, I would then go, okay, well, how big do I need to dig that hole? We could then come back and then work out, what it needs to be. And to be honest, it's funny, anyone who's actually done anything on stumps, I did heaps of it when I was in Queensland, and you laugh at that and you go, there's no way in the world that you would only put 150 mil, of concrete in there. Normally we just, whatever deep it had to be, and we would just fill the hole full of concrete. Yeah, that's fine, Valvan. You probably are a little bit lost, mate, and that's fine. So we'll actually do another one a little bit later on. So, or not later on, we'll do another one now. So what we'll do, guys, is have a little crack at this one here. And then what I'll do, the guys who are sort of a little bit lost and want me to go through it again, I'll do this one with you if you like. And if you feel like you're ready to have a crack at it, just let me bring up the other one this is one that's in your study, buddy. So, and it's got the answer guide here, which makes it a lot easier visually to look at it as well. So just give me a second and I'll bring it up.
Adam?
Yep.
Can I just share with the class and Valvan as well? I mean, things change with the VBA, but I mean, I've been doing this course now since September.
Yep.
Waiting for I've only just done my exam last week, and they said I'm probably still waiting 2.5 months to get my interview.
Yep.
My point being, I mean, obviously I've put the effort in. You got to put the effort in, but I understand exactly where Valvan is. I was the same at the beginning, especially like you said, this part is quite hard.
Yep.
So just for anyone who's struggling with it, at this point in time, unfortunately or fortunately, depending on how you want to look at it, you get plenty of time to figure it out, and now it's a piece of cake for me. So.
Yeah, and honestly, Valvan, and I get guys who I train who are carpenters who actually do this a lot, but they've never really had to work it out, and even they struggle with it as well. So yeah, mate, we'll definitely throw some exercises your way, and basically, and we'll make sure you understand it. So as Greg said, he found it a bit hard as well, but obviously with the time that he's had to do it, probably because unfortunately how slow the VBA are, you'll definitely, if you're ever not sure, just let me know and we'll just go over it as much as you need to. So,
just a quick question.
Yeah,
Greg.
mate. Yep.
I got my application in and it's been in for some time. How long since you got the first letter from them did you have to wait?
When I got the first letter, hang on here, let's just have a look. Just pulling out my file here. So I got my letter acknowledging my application November 22nd, and I did my exam on Friday.
Yeah. Yeah, and that sounds about right, to be honest with you. I know, like, because if I haven't told you, I run the face-to-face classes in Geelong and Ballarat, and yeah, the guys who finished that course and put their applications in when was it, the end of November, have only sort of just gone through in the last month. So I was under the impression that I know the VBA had a big backlog of everyone who submitted on the 30th of June, just because they changed the license applications. So everyone went, shit, I've actually been working on this, and it gave them a deadline to put it in. And I was thinking, you know, surely they've got to be through that backlog. But yeah, they just, I don't know. Hope no one's a government worker, but I think public servants work into their own time frame, I presume. So yeah, which is obviously unfortunate. So, and that's what I've found too, with a lot of the guys who actually, that I've trained face to face, yeah, how long can I keep coming to class? Because, and they sort of then gave it a break, and then basically once they got their date, because they were given, you know, how much notice were you given, Greg, until you actually had when they said, yep, come in for your test, how much time did you have?
I think it's about 2 weeks.
Yeah, most of the guys I've got have got 2. One guy had a bit less because they gave him the option because someone had pulled out. So a lot of them just went, yep, okay, well, I'm just going to wait until I get my letter. And then for the 2 weeks, they just then, you know, really studied the multiple choice and, yeah, just contacted me. And whenever I got anything new updated from the VBA, I'd email it out and say, this is the latest plan. So that's what some guys have done, because it's bloody hard to, you know, well done, Greg, and the other guys who have actually been coming, you know, every week for, you know, for how long? Probably 6 months. That's
why I'm doing the online thing, though, Adam, is because you don't realize this. I wander around my house and come back, and I'm not here the whole time. I just kind of keep it on and listen. And when you talk about something that intrigues me, I sit down. But other than that, so that's what I love about this, is it's not really inconveniencing me too much. Whereas the other one, you had to drive to, and you're actually sitting there, right?
Yeah, exactly. You might an hour to get there, 3 hours, and an hour to get home, and you think, oh, I already knew that. Yeah. So, yeah, but anyway, so what I'll do, guys, I'll step through this one again, and I'll put the answer guide up, and I'll email this over to you as well. So later on, you know, if you're someone who likes to have a crack over this on the weekend or after class, at least you can see, it gives you instructions on how to work it out. So what I might do is actually put the answer guide up, and then basically, so Valovan's just said that he's struggled a little bit with this. Is there anyone else who's struggled with it? Because if not, just go ahead and do it. And if you are struggling, you want to do it with me, just let me know so I don't sort of leave you behind, that's all. All right, cool, Valorant. So what I'll do, I'll put this up. Yep, cool. So we'll do this one basically together, Valorant. So if you can actually bring up your, like if you can do it on your paper copy, and I'll show you on the screen how we actually work it out. All right, so it's got, and I'll send this over too. So basically, you can see here drawn from above how it looks. So the one where this one is a little bit different, because if I can bring up one of these other pictures, bear with me just a second and I'll see if I can find it. No, 1 second, I'll just have to bring it up, mate. So this one here is basically going to be like this picture here. So it's got masonry up the outside, and therefore we've got these engaged piers. So when we don't actually have to design that part there. So let me just show you how that sort of fits in, mate, and hopefully this doesn't confuse you. So these ones here are going to be the engaged piers, which is basically our brickwork that the bearer sits on. So that's going to be designed basically from someone, yeah, not us basically, that's going to be done by engineering, and which in reality this is always done by someone else anyway. So we only really need to work out basically these rows of bearers through here, because we know there's going to be one on the outside, because that brickwork goes all the way up, like on that that other picture I just showed you. Let me just find it again, like on this one here. So that goes all the way up, and then we just start our brickwork in from there. So what we need to do is then work out basically these distances. So the first thing we need to do is, if we look at it, it says here that the space, we're just trying to work out how many rows of bearers that we actually need. So we're trying to keep it around 1,500. So what we need to do is work out, because it's an overall measurement, this is done this way to try and make you think a little bit more. I think it's a little bit too tough, but if you're wondering why, it's just to try and make you think a bit when you do it. Because it's from outside to outside, obviously that's incorporating our brickwork. So it says over here that basically bricks are 110 millimeters wide. So by the time we actually put those two bricks in there, it says here we've got a minus 220 millimeters off our overall measurement. So a minus 220, and then we actually minus another 50 millimeters, because there'll be a 25 millimeter gap of basically where our timber sits. There's a gap of 25 mil cavity between basically the brick and where our timber is. So 25 millimeters on each side actually gives us 50 millimeters. So let me bring it up on here. So just ignore these measurements a little bit, and hopefully not confusion with this part. As I said, I think this is a little bit too tricky. But anyway, it is what it is. So overall measurement is 48,550. So we actually minus our 220 for our bricks, so 110 on each side, so 220, and then minus 25 mil each end for the clearance for our cavity, so that's 50 in total, minus another 50. So basically our span, or our distance we're trying to work out is basically 4,850. So that's our distance there. Sorry, 4,005, I might have said that. You can see what it's meant to be. 4,580 is actually what it is. So because with these rows of bearers running this way, we want to try and keep them roughly at 1,500. So what we're going to do is go, and I'll let you, maybe as I do it, if you basically do it at home as well. So we're going to go 4,580 divided by 1,500. So I'm going to divide that by 1,500. And it equals 3.005. So it's really, with that one there, I probably would actually round that down rather than round it up, just because it's so close to that 1,500. So therefore we know that when we add our extra one on, that gives us that there's actually going to be 4 rows of bearers, so 3 spaces. So if we wanted to work out the exact spacing of our bearers, we would then use that measurement that was 4,580, and we divide that by 3. There we go, 1526 is actually what that spacing is. So that's, for some reason there, Steve's got, oh yeah, I'll talk about that, why that's a little bit different a little bit later on. So basically that's our spacing, basically from center to center of these actual rows of joists in here. So does that make sense so far, Valovan, how I've done that part there?
Yes, Adam, that's good, yep.
That's good, yep. All right, so, and it's sort of funny, yeah, it's going to be fractionally different to what they get in here, just because of the size of the members that Steve's used. So I'm just showing, and the thing is, there's lots of different ways to actually do this, and we can actually, like, we could, if there's 10 people here tonight, we could do this 10 times and all come up with 10 different sizes of timbers, and that would possibly still all work, because, you know, if we use different size timbers, they can span further and so on. So I just like to teach the way that I do it, because it makes sense to me, and I find that I can convey that message a little bit better. So that's basically how far apart these are spaced, is 1526. Now Steve's got 1503 there, and the reason he's got that, because he uses a different sized basically bear and so on. So just don't worry too much about that, we'll do it my way. So that's basically the spacing. So now we need to work out what the span is. So we do the same thing again. So I might just actually hand write these down, mate, so I don't actually get lost with what we're doing. So we've gone that our spacing is, so I'm just writing this down as we do it, 1526. All right, so the next thing we want to work out is then the span. So how often are we going to put these stumps underneath so that we can obviously support that bear as often as it needs to be. So we need, because it shows us the outside of the brickwork again, the overall measurement is, I'll just clear my calculator, is basically 8,250, and we need to minus our 220 millimeters for our bricks, and then our 50 millimeters for the 25 mil cavity on each end. So therefore that actual bearer, by the time we minus our bricks and everything, is 7,980. So what we're going to do is, like always, try and keep that at 1,500. So if we divide that by 1,500, that's going to equal 5.32. So I'm going to round that up to 6, and then obviously add the 1 to finish it off. So we need actually 7 basically posts under each end, or stumps, whatever you like to call them, but we've got 6 spaces. Because if we've obviously got 7, so what's he got here? He's got 1, 2, 3, 4, 5, 6. So Steve's gone a little bit different to me. So I've gone with 7, he's gone with 6. So I'm going to then, if there's 7 stumps, then there's got to be actually 6 spaces. So what I'm going to do is go that measurement. Oh, I should have written down what that measurement was. Sorry, the overall length. One second, let's work out what that overall length is again. So 8250 minus 220 minus 50. All right, so our overall length was
7980.
Yeah, 7980 is overall length. So as I said, I divided that by 15. Let's go again, divided by 1500, because that's what I like to have my stumps spaced at. I rounded that up to basically 6 and added 1. So that gave me 7 stumps. So if there's 7 stumps, there's 6 spaces. So I'm going to go that measurement again of 7980 divided by our 6 spaces. And therefore, our actual stumps will be spaced at 1330. Does that make sense?
Yes, it is.
Yeah, so Steve's got on here 1500. He's trying to work on 1500, but just the way, because I did a little bit extra, I got them at basically 1300. All right, so from there, because we know our spacing and we actually know what our span is, that's when we can actually go to our Australian standard. So I'm going to go to these tables at the back again, and we're going to work out our, oh, I'm going a bit too far. So I come to the span tables at the back, and as we said, we're doing bearers supporting single-story external load-bearing walls. I'll just see, mate, what type of roof that exercise has got on it. So we do the right. So it's a sheet roof as well. So basically, we're going to be using a sheet roof that's a continuous span. So it's going to be A4. So we go to table A4. And where is it? So that one there. Oh, sorry, I've gone the wrong way. So this is it, table A4. We've got bearers supporting single-story external load-bearing walls, sheet roof with a continuous span. So if we look, we need to know obviously what our truss span is. So if I come back to here, our truss span is roughly going to be just under 5 meters. So we can use this table here because it says if we're basically an unstrutted roof with a maximum rafter span of basically 3 meters, or a truss roof up to 6 meters. So we use this table here. So it talks about our bearer spacing. So on this one here, our bearer spacing was just over 1500. So I'll actually have to use this table here, which is the 1800 one. And so from there, our bearer span, so basically how often our stumps were, we worked that out to be around about 1300. So therefore, we're going to use this one here, which is basically 1500 because it's bigger than 1200. And we come across to actually our F17 table, and we're going to use 290 by 35. So 2 bits of basically 90 by 35 basically fixed together, and that's what our bearer will be made up of. So if I look at basically this drawing that Steve's done, it's going to look like this. So does that make sense? So we've got two of them side by side, and then our stumps are obviously going to be underneath like that. So does that sort of make a little bit more sense now, Valavan? I know it'll probably take a few guys at getting used to, but does that sort of starting to make a bit more sense now we've done it again?
It is, Adam.
Yep.
Just one question on the last bit that you mentioned.
Yep.
And you said like a truss span is under 5,000, therefore we are using that table, and
Yep.
that part I didn't get it.
Okay, yeah, so this part here, because basically when we look at our table here, so this is working out our bearers, and when we look up the top here, because this depends on how big because obviously like the bigger the truss is, the more weight there's going to be that's being transferred through our walls and onto our bearers. So that's why you need to know basically how far that truss spans. So when we look at our picture here, our truss span is from outside to outside is roughly 4.8 metres. So when we come to our Australian standard, it shows us here, when it talks about our truss span. So this one here is for if you're using basically an old-fashioned pitch roof, which is up to 3 metres, which we're not using. This one here is if it was a pitched roof, basically up to 3 metres, or trusses that span up to 6 metres. And then you come down here and we've got trusses that span up to 9 and trusses that span up to 12 metres. But because our truss span is basically no greater than 6 metres, that's why we're using this table here.
Yep.
Yeah. So does that make sense now?
Yes, it is. Yeah, thank you. Yep.
Yeah, cool. So that's how we would work that out. And then, so what I'll see if you can do this little bit on your own. So if we come back to this part here and we work out basically now I'll let you work out what our floor joists are going to be, and I'll put it up on my screen as well, and we'll go through it after you find your answer. So now the next step we want to do is actually work out what our floor joist is. So if I bring up the picture that Steve gave us, so these floor, as we can see, the spacing basically between our bearers, we worked out that was 1,500 and something. I think it was 1,526 was the spacing. So that's then the measurement you'll use to work out your floor joist. So if we come back to our table and you go basically our floor joist table, which is table number A8. So if we go to A8, and this is it here. So basically you're working out, it's going to be a continuous span. So basically all you need to do is work out basically what our joist spaces are going to be, and we're going to put them at 450 millimetres. You either have 450 or 600, and then you just work out from there how far that's got to span, and you just basically line it up with the F17 table. So you can either use what's on the screen there or use your own book and see if you can figure out what size you think that joist needs to be.
Okay, sure. Thank you. Yeah.
And what I'll do, guys, when this is all done, I'll put that, I'll definitely email this to you as well. So what this answer guide is, it sort of talks about how Steve likes to do it as well. So, as I spoke before earlier, there's lots of different ways to actually do it. And that's just the way that I do it, and I think it makes more sense for me to train it that way, because then I'm sort of confident in what I'm saying rather than going, oh, this is how Steve does it. I don't know how he does it. So if you want to know who Steve is, Steve's a training manager, guys. So I'll email that over, and that's just his version and basically how he's worked it out. But yeah, I'm sure you guys will be able to figure it out. If you've got any questions, just let me know. And just let me know when you're done too, Balavan, so you're not waiting forever for me.
Sure. Yep.
Yeah, there's no hurry either, so whenever you're ready. I just want you to be here waiting for me, and I was waiting for you.
Should we go for the spacing as 1500 or 450?
So the spacing of the joists is like how often we're going to put these joists. So we'll go at 450 and say we're spacing them at every 450 millimeters. So if I bring up this picture that Steve's got, and hopefully he's got it on there. No, it just shows the joist going straight atop. But if you could imagine where my mouse is, the joist would be running this way, and they would be every 450 millimeters we would put one there. So our spacing is actually 450 millimeters, but how far they're spanning is basically from one bearer to the next, which we worked out, which was roughly about 1300 millimeters. So if we come to that table, we're going to use the 450 spacing. And the reason that determines is also sort of what type of flooring you've got on it. Because if you've got the yellow tongue flooring, you've normally got to have it spaced, like supporting underneath that yellow tongue at 450 centers. So our joists are going to be every 450, but as far as how long do they actually span, we'll use this 1500 because we worked out it was roughly 1300. So we can't use a 1200 because it's bigger than that. So we go the 450 and then the 1300, and we come across to our F17 table because that's what it had we were going to use, and it's 70 by 35. So that's actually the size of our joist there. So, and what we'll do, because we'll go on to some other stuff after this, but basically I'll draw up a couple of things, Valavan, and I'll email them over to you. And when you get this answer guide, you'll be able to, basically read through. There's a few instructions there, and just email them over to me and say, hey, Adam, how did I go with this? And yeah, mate, if we need to do another 5, we'll do another 5. All right,
sure. Yeah,
cool.
Thank you.
So the other guys, what I'm going to do, we'll have a break now. Give me like a couple of minutes and I'll email over this answer guide to you. Then that way you've all got it. Now, if anyone, I said, because there's so many different scenarios we can use and still be right, if you think that you're not quite sure, just email yours over to me and I can have a look at it and give you feedback on it. But it's one of those things, once you know how to do it, most guys go, yep, I'm all good with that, and you sort of know that you've got it right. So if you want me to have a look at your own version, email it over and I'll send these answers over, and we'll have a 15-minute break and we'll come back at 7:45. And so if you're talking to me in the next 15, I probably won't be because I'm just going to go and grab a drink of water. But we'll be back here at 7:45 and we'll go on to the next part. So I'll see you then. All right, guys, welcome back. Just bear with me 1 second. I'm just going to bring up this bit of feedback I got from a student, and if Greg's around, I wouldn't mind getting your feedback on it too, Greg. So bear with me a second. I'll just bring it up.
Yeah, I'm here.
All right, cool. I'll just bring it up and yeah, get your take on it. Because as I said, he couldn't really 100% remember it because he was sort of that I shouldn't say he wasn't flustered, but sort of felt like it was information overload in the 2 hours. So this is just sort of a little bit of feedback that he gave me. So bear with me a second. I'll just bring it up. All right, so that's one of the things I want to talk about. And hang on, I'll just bring up the other one. All right, now totally different plan, but what I'm trying to do is just show you guys the shape and also get Greg's feedback on it. But one of the guys who I trained in a face-to-face class was telling me that when he had to work out the actual raft slab, they had like a little, he called a bay window that was something like this, and it came out about 600 millimeters. Does that sound right, Greg, or were yours just straight walls all the way through?
Yeah, no, there was like that, and there was also a fireplace like that as well. So
Okay. Yeah, so
there was
what,
few
sorry.
little jogs around there.
Sorry, mate, just say that again.
Yeah, there was a few little things like that, like more than one on the plan, yes.
Yeah. So what I wanted to, as I said, I'm waiting to get a bit of, and I wouldn't mind, Greg, if you can maybe in the next day or so draw, if you wouldn't mind just sketching it up to how you thought it was, because what the way he explained it to me, and this is sort of covering what we did a little bit last week, is that if we're doing a raft slab, let me just shrink this a little bit, that you can see here that that's like obviously basically a corner with the reentrant that needs to go all the way through there like that. And he thought that when it came to these measurements, they didn't stick out far enough to warrant having that reentrant going all the way through. And so when we spoke about it, and because he couldn't remember the actual basically like the measurements on the plan, when we pulled up the Australian standard and had a little bit of a chat about it, and I'll bring that up in a second, my Australian standard. Basically, so I just want to, in case someone's going into the VBA in the next week, and I just thought I'd cover this because I just don't want to draw something up and it not be totally accurate. But he thought it might have been this part here, where you can see there's a reentrant corner, and it tells you that the offset of that reentrant corner is less than 600 millimeters. So therefore, with these other ones that we've done, we would have previously had, like this basically beam coming all the way through, but because it's obviously less than 600 millimeters, then we can just keep those at our beam spacing, whether it be 6 meters or 5 meters or 4 meters. But what we'd have to do is obviously have that pad of concrete in there, which is basically whatever 2 times the depth of the beam is. So does that sound like that might have fitted the drawing you were doing, Greg, or do you think that those step outs were big enough that you would have had to have basically drawn those? I've lost my sheet here. Give me a second. You would have had to draw them all the way through.
Yeah, well, that's what I ended up doing, because as I said, what ended up happening is I first of all, I realized, because for the slab it was 4 meter centers for all the internal beams.
Okay.
And so I kind of set them all up, and then, as per normal, you start drawing and you realize you haven't got them centered and they're just not right. And so I kind of said,
Yep.
oh, evenly spaced, blah, blah, blah. And then as I kind of look back at it, it was just one of those things where I think I went on to the next question and then came back and I went, oh, geez, I forgot all the internal corners.
Yeah, okay.
So I quickly scratched all of my stuff up, and then I just drew everything quickly, every single internal corner, made sure it went through.
Yep.
And that's, interestingly enough, yes, there was one, that little nudge out was 450. However, I thought it was a fireplace, that one, and that one, you suddenly got to be like, well, wait a second, if it's brick all the way up and fireplace, tends to be a lot more weight there.
Yeah.
But what I ended up doing was I just ran them across, but even the way the spacing is with four meter centers, and the amount of corners, there was so many internal corners. Like we had to draw all the re-entrant bars as an example, Adam. And I think there was 8 re-entrant bars we had to draw.
Yeah, okay.
Like there was that many corners. It was just like it just jig-jogged all over the place. But when you ran the internal beams across, they were pretty much lining up with another corner on the other side, or if it was pretty close. That's where I realized I could have probably done an internal beam on an angle and caught it.
Yep.
But it was also close enough. I just thought, no, I'm just going to put it on every single internal corner anyways, because it was pretty much 4 meter centers, approximately, give or take, when you looked at it that way.
Yeah, and that's what I said to him as well, because he did pretty much what you did. And I said, look, I'm sure without seeing the diagram, I don't think that would be wrong. Just the Australian standard, I'd say this is one of those things where it makes an allowance for you, if that makes sense. So if you didn't want to put an internal beam, then this is what you can do. So
and I made reference to that on one of them, because as I said, when I brought the beam down from the opposing internal angle, it was offset from that internal corner. And I made reference, I'm like, I'm going to put a nudge out like this at, as per figure 5.4 AS 2870.
Yep.
That's what I made reference to that. However, at the same time, I realized after the fact, I could have run the internal beam on an angle. You don't actually have to run it on
exactly. Yeah, as long as it doesn't go past that spacing, then exactly.
Reality is they can't fail me because the strip footing will pass. It's maybe overdone, but it will pass.
Yeah, exactly. Right? Yep. So so that's just want to show that, guys, because I know we did some of the strip footings last week, and I said we'll get some feedback, because no doubt we had a fair few guys go through on Friday, and normally in a week or so someone draws something up and says, okay, this is what they're asking, this is how it should look. And so this, if you do go in the next week before you get that, I just wanted to show you that, because you might look at that and go, okay, that makes sense with the drawing that I've got. So that's in the beam continuity in rafts, and we did cover that last week. And then we sort of covered this part, but we hadn't actually had any feedback on that. So it's on page 52, and maybe just be aware of it if you do actually happen to go in the next week before you actually get that. So cool, thanks for that feedback on that, Greg.
One thing, I'll just give you a quick feedback, and everybody that's got tests coming up, don't worry too much about this, but it's more for Adam. What I thought was quite tricky that they did is they actually wanted you to comp up a beam for a little outdoor kind of alfresco another one of those little corners, but a bigger one.
Okay.
So you definitely have internal beams for those ones, but they wanted you to comp up a F-17 across there, which was supporting the roof, and because it was a brick veneer, you had to be careful with obviously your beam doesn't bear on the brick, it has to bear on the internal wall, and then as soon as you measured it out for the internal wall, it nudged it up into the next beam category. It went from like 3 meters to 3.6 or something like that, because it was just
just a little bit extra.
The measurement on the plan was like 2980.
Yep.
You add the brick, it was like 3.3, which meant you had to go up, and I thought that was one that they were trying to trick.
Catch you out on.
Get you out on, right?
Yeah,
so,
okay.
Anyway.
All right, cool. All right, thank you. So just got a question here from Tom. So give me a second, Tom. I'll just open that question up, mate. So you're talking about like the cantilever, Tom? Is that basically what you mean? Or are you talking about the beams? I know you're saying for the beams. So is the 1 in 3 angle apply for all beams, even on one side of the house to the other? So you're talking about this part here, Tom? You're talking about the angle in here?
Yeah, so if you had 2 jut outs each side of the house, so 2 internal corners each side of the house.
Yep. Is
that 1 in 3 angle, can you still run it through them 2 jut outs?
Yeah, it's not something I know off the top of my head, but I'd have to have a look at it. But yeah, I'll have a look and I'll let you know, because I think you can, but I'll have to, as I said, I couldn't tell you straight away. So when you guys are doing a bit of an exercise tonight, I'll basically have a look through it, and if I don't get a chance to do it tonight, I'll have a look and I'll send you an email on it.
I'm sure you can.
Yeah, exactly. I'm pretty sure you can do it. I just didn't want to say definitively yes without actually reading the book on it.
Well, how else would you do it?
Yeah, exactly.
You know what I mean?
Exactly.
Because they were, and that's the way it was in the plans. There was a couple of them that were literally on the exact opposite side of the house. So. Yeah.
Okay. Yeah. I said, yeah. I'd be very certain you could, but I'll definitely find it. Someone if we want to reference, we can say, it's on this page. Let's highlight it if you need to. All right. Cool. So what I'll do, guys, so basically I'd like to just go through some stuff in our Australian standard, and then that way just to highlight some stuff on our subfloors and also that we need to be aware of. So basically for tonight and for next week, we're using Australian Standard 1684, which is our residential timber framing code. And so I'll bring that up. I'll get rid of this subfloor one so I don't get confused. And just some stuff that I think that we won't go through it all tonight, just the parts that are relevant to tonight. So this one here, so our 1684. And just be aware, because this is probably last week and this week is the first time, if you're doing the course for the first time, when we touch on using our standards rather than our legislative acts and regulations. And so one thing that we see basically in our industry all the time is, and this will trip you up in your multiple choice if you're not too familiar with the course yet, is you'll see there stuff, how long is a concrete slab basically, it's how it's stated in Australian Standard 2870, and we'll talk about how long that slab is. You think, well, I've done slabs longer than that, so we actually would pick the answer that we think we've done a slab on, as in the length. It might be 40 metres or something. But just be aware the Australian standards actually have limitations on them, and so some things that pop up quite often in your multiple choice and is basically sort of a bit of a trick question like that. So I'll show you some of those when we come down here. So if you're ever not sure, it's actually under limitations. So this Australian standard that we're using at the moment, and I'm on page 8 here, only deals with class, basically as far as the wind rating goes, N1 and N2. And it talks a little bit later on, down here, what an N1 wind speed is and an N2 wind speed is. It's got it in here. So, but you probably won't get that so much, but this one here you might get is actually like the number of stories. So the Australian standard is 1684, and this is on page number 8. And I've actually got these highlighted. By the time you guys actually do your testing, if you're using our multiple choice, these will probably all become second nature, but I would definitely highlight these. So this Australian standard only deals with basically buildings that are a maximum of 2 stories and of timber framing, and then it says and also the width. It actually doesn't deal with anything wider than 12 meters, and that's excluding the eaves. So there's a couple of things which are called the limitations. So I'd highlight that one in your book. So and we'll do others too when we talk about concentrated loads and stuff like that next week, but I just want to cover these off this week. So another few others here, which is basically our wall height. So this Australian standard only does wall heights up to 2.7 meters. So that's from floor to ceiling as measured at the external walls, and it gives us a figure there of 1.1 of how that's actually done. The rafter overhang, so it says the maximum rafter overhang shall be 750 mil. The roof pitch, the maximum roof pitch is basically 30 degrees or 58 to 100. And so then we talked about our rafter and trusses. The maximum spacing of rafters or trusses shall be 900 mil for a tiled roof and 1200 mil for our sheet roofing. And then bracing, so the spacing of bracing elements measured at right angles shall not exceed 9 meters. And we'll cover that next week in more detail when we actually work out our bracing units. So there's just a couple little things to highlight when you're doing your multiple choice that you might actually get. And so I'm just flicking through my hard copy here, guys. So if you're not overly familiar with a lot of the different framing terminology, and this will have a bit more to do with next week when we start working out our basically the different sizes of our members. Is 1 second, I'll come down here. Is this table here. So if you're actually not 100% sure of the different members and what they're called, there's actually a picture there and shows us probably the ones which a lot of guys aren't overly familiar with is the stuff in our conventional roof or our pitched roof. And so that's our hanging beams and our collar ties and so on. But that one there's more your wall framing and your subfloor, and I'll show you some pictures later on that show us how our pitched roof construction. So I'll cover these ones a bit more next week, so I'll just flick past the stuff that's making a bit of sense tonight. Because that's all to do with wall framing. that does there talk to you about basically what a span, a single span and a continuous span is. So if you're not familiar with that, guys, I said I did show the one in the building code, but if you think that makes more sense to you, you can highlight that on page 23, where it's got, you know, our single span, continuous, and what a span is. And then this is going to tie in with what we were doing basically earlier tonight. And there's some pictures too, guys, showing you single span. You know, obviously it's between 2 points, and you can still have basically these single spans here because they would be joined there where it says the saw cut, and then that's our continuous span. So that's probably a visual on your basically single span and your continuous span if you didn't like that one out of the building code. And so this party, we did talk earlier tonight when we spoke about our footing classification. I said, you know, once we work out the size of our bearers, basically just because the bearer says it can span 3 meters, we have to actually find a footing type that allows that, and that's why we try and keep it around that 1500, and we can always use a footing type 2 or type 3. So with those footing types, it might be something you'll get basically in a multiple choice about what that bearing capacity of the soil needs to be. So like when we did our slabs last week, and we spoke about, you know, the bearing capacity of the soil, you know, for raft slabs and so on. It's the same here. So it says footing types 1 to 4 are used for use in areas where allowable foundation bearing pressure is at least 100 kPa. If we're going to use a type 5, because it's so much bigger and has to hold so much more weight, it actually has to be 125 kPa. So that might be something you'll get in a multiple choice. So I would just highlight that, because if you're looking, this is obviously going to be in our substructure section as it shows us up here, and to do with our footings. But yeah, if you have to find out what your KPA is, that's actually listed there, and some guys find that a little bit hard to find. And I've just basically got that highlighted as footing classification. And because then when we turn over to the next page, this also then, I did show this earlier, talks to us about, or doesn't, shows us how big that footing needs to be. So that's our footing type 1, 2, 3, 4, and 5. And then this talks about how big it needs to be. So if it's going to be a square, 230 by 230 and 100 mil deep, or basically if it's going to be a cylinder, a 250 millimeter diameter by 100 millimeters deep. So that there talks about how big the minimum size of the unreinforced concrete pad footing needs to be, basically around our stumps. So this here basically talks to us also about what our stump and post sizes need to be. So I actually haven't had anyone where they've had to work out basically the post and the stump sizes, but if you didn't need to, like that exercise we did tonight, if we wanted to go that bit further and work out the size of our stumps, then basically this is a table where you would, you know, be able to do it in here. So it talks about, you know, what footing type you've got, and then, you know, what type, because obviously the timbers are different strengths, and they, you know, you look at your F4, and because it's a weaker timber than F14, on these ones down here, on a type 4 footing, you have to be 150 basically diameter, whereas down here it's only got to be 115. So that there talks about the stress rate of the stump and what it would need to be in relation to that footing type that we're using. So, and then a couple other ones here, same thing, nothing that anyone's given any feedback recently on, but I think it's worth just highlighting. And this is the height of the stump of what it needs to be above the ground. So it says the height above ground, any stump or post determined by using table 3.2 shall not exceed 15 times the required minimum face width or the diameter. So basically whatever size that post is, then you know, it shouldn't be 15 times. If it's going to be 100 by 100, then basically 15 times our basically our 100 millimeters is how far, you know, it shouldn't exceed. And just remember too, we're all probably going, geez, I've actually done that before. And I'll get to that in a second, Subit. So yeah, so just remember, this is as per the Australian standard. We can get stuff that's you know, engineer designed. You know, we could have steel stumps and concrete and so on. This is just dealing with our timber framing manual here that we've got in front of us. So the stress grade, Subit, to be honest with you, I have not done one. I don't know if you guys can help out here. All the stumps that I have done and I've done heaps of them, were either concrete or they were actually steel. So I could not tell you the last time that I actually did timber stumps. I'm guessing, well, what would you guys use? Would it be F11 or F14? Anyone actually? Subus just asked me a question. What is the most common stress grade with the timber stumps? And what do you guys use if anyone's done? Are you using F11 or F14? I would presume that's probably what we're using, but I'd only be guessing, as because mine have always been steel or concrete. Anyone out there using timber stumps?
I used to work in the milling industry, so I've never seen anyone use it for stumps.
Yep.
But your most common thing is going to be F7, which would be treated pine.
Yep.
Like readily available. F8's Oregon, but you can't really use Oregon in ground. So F7 or F11 and F14 is when you get into your hardwoods. It's the same thing. You really can only use probably like spotted gum and whatnot to go in ground. So it's most likely F14. So you're really either going to be F7 or F14 or higher.
All right, cool. There you go. Thanks, Greg. And that's probably why we normally use, I presume, the concretes are pretty standard, where they've got the basically the reinforcing rod sticking up. You just drill a hole in your bearer and then basically place it through the hole and knock it over. And that's probably why we don't use the timber much, I presume, as well. All right, so it does talk here a little bit then about the embedment, and so basically that's talking about the stump or the post, basically how far it's got to be embedded into the foundation material. So it says it's got to be at least 0.3 times the stump height above the ground level, or 450 millimeters, whichever is greater. And there's a picture or somewhere which we'll come to, which actually shows that, I'm pretty sure. But yeah, there is something you might get in basically your multiple choice. And here's some other stuff too on our bearer spans for footing types 1 to 2. And so tonight this is bearer supporting floor loads only. So the ones that we were doing tonight were supporting basically load bearing walls. So if you did actually have to do one that was only doing basically floor loads, there's a different table there, and your spans will differ slightly. All right, so this is a table we were using tonight. So that's probably the most common one you're going to do if you have to use a subfloor to basically work out bearers that actually have our with the load bearing on them. So that's how I was saying before. I always try and keep it under 1500. So then I go, yep, well the bearer spacing isn't greater than 1500, and then I work out what my truss span is, and then basically line those up, and it gives me, whether it's sheet or tile, what type of footing type I need. And so that's that part there. I've definitely got that basically tabbed and highlighted basically in my book, and I've just basically got it written there as basically footing types, and I've got 200 footing types, that one there. All right, so I'll keep scrolling past those. It's just a continuation of that. This stuff here has got to do with our subfloor, and basically our like our notches, I suppose, in our penetrations. So I've just got that highlighted as well. It just might be something you'll get in a multiple choice. So that's on page 31, and I've just got basically a little tab there that's called notches in bearers and joists. And so that basically shows us, depending on the size, basically it's basically got ratios there of 3 times the depth, or 1/3 of the depth, or whatever it's going to be, or maximum 50. And so on. So yeah, lots of different scenarios. It's going to depend on what size timber we use to actually how big that hole is going to be. But you just use the ratio that it gives you. All right, the other ones I've got, bear with me a second, I'll scroll through. So one thing that I like to talk about is probably just not too much. It's probably the terminology that people haven't heard. So this is deep joists. So what a deep joist is if we look at the picture here, I'm sure it shows us. It doesn't work out great in the PDF, but I'm actually on page 34, and some of these symbols don't work very well down here. But basically a deep floor joist is basically when the depth of the joist is basically 4 times greater than what the width is. So if you can put that into perspective, if we've got something that's 50 millimeters wide, so let's say these joists here were 50 millimeters wide but they were 200 millimeters high, then that would be considered a deep joist, because it's basically 4 times as high as what it is wide. So when we've got something that's going to be a deep joist, it explains here that we've got to put solid blocking or a herringbone strutting in between there. It doesn't actually give us a picture of a herringbone strutting. I don't think anyone uses herringbone anymore, guys. It's like little timber braces that sit in between the joists. So let me just Google it just in case someone actually is wondering. I'll Google an image and put it up. Bear with me one sec. Oh, here we go. How good's that? So there's some pictures of herring. That's probably a good one there. No, it's only a drawing, but that's basically, there's a picture of one. So basically you would put that in between your joists, and what it does, it stops them rolling over. And so you can see probably how time consuming doing that is compared to obviously putting in our solid blocking like that. So that outlines that, if it is going to be a deep joist, we need to either use that herringbone strutting or the solid blocking, and they can't be any further than our basically 1.8 meters apart. And so it talks a little bit more for deep joists in unseasoned timber where the span exceeds 3 meters and there is no ceiling installed on the underside of the joist. Herringbone strutting or solid blocking shall be provided between all joists in evenly spaced rows, not exceeding 1800 millimeters. So yeah, just I would highlight that to do with your deep joists. It might be just something you'll get in a multiple choice, but the picture sort of shows you a little bit. And these, if you look at your hard copy, yeah, it'll make a bit more sense because that doesn't work out that well in a PDF when that comes up. All right, I'll keep scrolling on. So I've just got my hard copy here in front of me. All right, so one thing we did do earlier tonight, guys, was talk about with those floor joists, and we looked in the table and it said floor joists supporting floor loads only. So there is actually a picture here, and we probably, I don't know, we might have time to do this tonight. So let me bring this other drawing up. Right, so this drawing here, this is one, we'll probably attempt it tonight. We probably won't get it all done, and that's fine. It could be something that you guys, if you feel like you need a little bit extra work on it, you can do it in your own time, but this is sort of, no one's getting this in the VBA at the moment. It's a pretty hard one. But basically, oh, and that's not. So what it is here, these are going to be internal load-bearing walls. So when you guys do this exercise, and we'll probably start it tonight, oh, sorry, I just saw your thing there, Tom. I'll share that in a second. So we're going to run our bearers long ways, and because they're going to be load-bearing walls, we want them actually sitting above where our bearers are. And so that doesn't always happen, and that's when we would then have load-bearing joists. But it shows us in it's Australian Standard when I bring it back up. Oh, wrong Australian Standard, sorry guys. Basically how far we can actually offset that wall, and then it basically doesn't become a load-bearing joist. So it says where load-bearing walls are offset up to 1.5 times the depth, sorry, the joist depth from the supporting bearer or wall, the joist may be considered as supporting floor loads only. So if we look at this here, whatever our depth of our joist is, let's just say, to make my maths easy, if it was 100 millimeter deep joist, we can times that by 1.5 and gives us 150 millimeters. So if the distance from that bearer to that wall is no greater than 150 millimeters, then that joist can be considered to be floor loads only. But as you can see, that basically once it actually is further than that, then it's going to become basically a load-bearing joist. So that's when you're doing this little exercise later on tonight, if you get a chance, or on the weekend, if you work out your spacing, and ideally I always try and just put them straight underneath it and then basically put one through the middle and do it that way, but everyone does it a bit differently. But yeah, you can basically make sure it just doesn't offset by that 1.5 times, and your bearer doesn't actually have to be directly underneath it. So yeah, if you want to highlight that, that's just called floor joists. What have I called that one? All my tabs are starting to break off, probably like your guys as well. You can probably just, I don't call it load-bearing joist if you like, if you haven't got one in there already. All right, another thing too, you want to be aware of, might be just a multiple choice question. So, here's something that's wasn't what I was going to talk about, but I've just seen it. Just for your own knowledge too, this is doing basically with our flooring. Normally when we're doing stuff that's on a yellow tongue floor, we just put our bearers and our joist down and put the yellow tongue floor all the way across. But if we're doing what I call a fitted floor or cut-in floor, that's sort of like your old-fashioned tongue and groove flooring. And we used to do all that when I was in Queensland because everyone had tongue and groove flooring up there and we were doing renovations. That if you're actually basically putting that flooring in, you've got to have a gap of basically, this one over here, 10 millimeter gap, basically between your last board and your wall. And that's because our timber contracts and expands. If you do it hard up, when that timber expands a bit, it's going to pop your floor. So you always want to have a little bit of a gap there. And then by the time you put your plasterboard on and then your skirting board, it's going to cover that gap anyway. And also when we put our joist down, there needs to be a 12 millimeter bearing, so at least 12 millimeters of that flooring sitting on the joist. So, but the part that I wanted to show you is this one here. So this is a pretty important one to know if you're not familiar with it. Next week we will actually cover bracing and what we actually have to do to actually make our bracing comply as far as the angle it goes on, what size nails, if we're using ply bracing, how often do we have to nail it. And this is the same thing with basically our particle board flooring. So when we're using a yellow tongue or our red tongue, basically you can see here that our joins are staggered. So you wouldn't put two joins directly next to each other. And the nailing pattern talks about how it's got to be 10 millimeters in from the edge and basically 100, it says 10 millimeters from edge at 150 centers at the ends. And then over here it says basically these ones here are 300 millimeters on the intermediate ones. So that might be something you might get in multiple choice. But yeah, if you wanted to highlight that one there, and whether you decide to tab these or not, it's really up to you. I've just got a tab there called flooring. I find that most guys, when they do the course, by the end of the course, they can navigate their way through the book pretty easy, and they just have the highlight there to direct their attention to it. Because if you start putting tabs on everything, it starts to get a bit confusing, especially in this book. You'll end up with 40 tabs in it, and that becomes more confusing trying to find the right tab. But if you did want to put a tab there, I've just called mine flooring. All right, I'll scroll down. That's a little bit there. I haven't got that tab, but this is Steve, the training managers. He's done the PDF and highlighted it, and he just got basically talks about our decking. And so, especially those guys who are probably doing, if you're doing structural landscaping, might be something you'll get asked on because obviously you'll be able to do decks. And it talks about basically, the span of what sort of different types of decking we can use, what we have to put the spacing of our joists on, so that obviously that decking can span that far. All right, we'll cover this one next week in our wall framing. That's all good. And we'll cover these next week in our wall framing, so we'll leave those for next week. So I'll just scroll down a bit quicker. There's nothing there for a little while. All right, so when I was talking, now we'll do that next week. And I was talking about our basically before about our pitch roof, and when we're working out our load-bearing walls for our bearers and so on underneath them. Here's a picture if you do get stuff in your interview talking to you about different components of what I call a pitched roof. They call it here a coupled roof. So I'll try and use the right terminology. So a coupled roof. Basically this tells us what those components are. So if you're not too sure when it says an underpurlin or a collar tie, basically you can look at this picture here on page 59 and it gives us a few definitions on not definitions, basically a diagram showing what each of those members are actually called. All right, and this is one, if you guys are doing the multiple choice and you're probably looking at, you probably know the answer for this question, but probably thinking, I got no idea what that actually is, but I know what the answer is. And it's about counter beams, and it says something on the lines of, what is the minimum clearance, basically of a combined strutting counter beam to the ceiling lining. And so the answer is 25 mil. If you've been doing that multiple choice, you probably know the answer. And I always, try to picture it in my head. And if you're a bit like me, and probably a bit like Greg too, we like to sort of try and understand everything. So that's actually that picture if you're doing the multiple choice, you didn't know what it was about. That's for the guys obviously doing the DBU, DBM, and probably the carpentry. So that's your counter beam in the middle, your hanging beam on either sides, and obviously you've got your clearance to where your ceiling lining is going to be, got to be 25 mil. All right, I'll just scroll down a little bit further. One thing which you probably also get in a multiple choice is talking about collar ties. So I'll just scroll down to it. Sorry, next page. So this one is talking about a collar tie. So the collar tie is that thing there in the middle, guys, and what it does, as the roof flow gets pushing down, it sort of stops that ridge, I suppose, dropping and sort of spreading that out. So our collar tie, it says here, collar ties shall be provided in all couple roof construction. Size and collar ties shall be in accordance with table 7.5, and it talks to you about how often we've got to put them in. So shall be fitted, yeah, basically. So whether rafter span is such as to require support from underpurlins, collar ties shall be fitted to opposing common rafters at a point immediately above the underpurlins. So you can see here, that's our underpurlin there. That's where they've got to go. We don't put them way up here or down the bottom. They've got to be above the underpurlin. And this part here too, collar ties shall be fitted every second pair of common rafters. So we've got to put, that might be something you'll get in a multiple choice. So every second pair, or at 1200 millimeter maximum spacing, whichever is less. So yeah, that's basically what the spacing of our collar ties are. All right, for the guys who you might get a drawing. It's not something they're asking at the moment from the feedback I've been getting from the guys going through. But if you do need to actually do some drawing and you're not a chippy, you don't understand how eaves do, this is basically a couple of different ways that the eaves can be done. So each to their own how they do them. I was taught as an apprentice to do them this way, but I see most construction now pretty much doing it this way here, where they put it back to the wall frame. So just be aware, if you do get to draw it, there is actually a section in there that says eave construction on page 70. And yeah, you can basically show you how to draw in your eave construction. All right, we're going to do an exercise next week, but I don't know if you want to basically highlight and tab this. The only reason being is that it talks about our ceiling batten sizes. So as the course goes on, we get used to going to the back tables, our table index, and actually basically looking through there for how big a member's got to be. And this is probably one of the only ones that's not at the back. So a lot of people go to the back trying to find their ceiling batten size, and they can't find it and go, it's not in here, and that's because it's actually on here. So I don't know if you guys want to highlight that and tab it or just highlight it, but I would definitely be making note of it somehow, because if you do get something that requires ceiling batten size, it's pretty bloody hard to find, because we're normally going to the back of the book. All right, and I think the rest of the book is probably bracing and wall framing, which we're going to cover next week. So a couple of exercises I thought we'd have a crack at tonight for the next sort of half an hour is, give me 1 second, I'll just bring it up. What I'm going to do, I'm actually going to close all these down. I've got too many bloody things open. So this one here is the one that I was saying, guys, that I thought was pretty hard. So I think it's worth having a crack at. If someone thinks, hey, look, I'm not up to that yet, basically I'll draw up a little one now and I'll scan it and email it over to you. But what we're going to do here, that's a concrete floor. So obviously we're not going to do the subfloor on this one here, but it gives us a little bit of information. But if you want to do a subfloor layout, it's a conventional roof. So, or as the Australian standard said, a coupled roof. So therefore we know when it's got a coupled roof, that when we look at those pictures I had up before from the Australian standard, it's going to be supported down onto our load-bearing walls. So that's going to actually make basically this wall here load bearing. So when we actually run our bearers through, what I do is I do pretty much exactly the same what I did last time. I still try and work it out on 1500, but what I'm doing is obviously running them on the outsides, because I know they're going to be bearers on the outside, and then I'm going to run one directly underneath where these load bearing walls are. If I know that I've got obviously one bearer going under that wall and then one bearer going under that wall, I'm going to get that distance and basically try and not make them any further than 1500 millimeters apart. So if it worked out that they were, 3 meters apart, I would just chuck one straight down the middle, and therefore I know my bearer spacing on those two is no bigger than 1500. So our bearer spacing, guys, they don't all have to be exactly the same. You know what I mean? They don't all have to be exactly 1453 millimeters. So that's the way that I do it, is put the load bearing points first, and then I then try and space out my other bearers so they don't exceed that 1500 millimeters. And then as far as them running where my posts are going to go, I just do exactly the same as what I would have done previously, just gone the length of what the bearer is going to be, and divide it by 1500 to work out how many posts I need. Now there's going to be lots of different answers for this, because I've seen when guys have done it, when they've run a bear along this wall here, they've run one basically right next to the brickwork and then stopped it at the end, and then they've put one in the middle basically of where this load bearing wall is, and then this one, because that gap there was too big, and they've run it down the middle. There's nothing wrong with that. And I've seen other guys with what they've done, they've actually carried that all the way through and just had a bigger space on this side than what they have on that side. But just be aware when it comes to working out our other members, when it says your bearer span, or sorry, your bearer spacing, you're going to have to know what your biggest spacing is. So if they're all different, work out what your biggest one is, and then when we go to our span table, just use that number. So if you find one is at 1500 and all the others are at 1300, use a 1500 bearer spacing. So has anyone actually done this exercise before? Because I know a lot of the time when we do this in class, quite often the guys sort of run out of time, I suppose, to get it finished. So yeah, I'm more than happy to, basically, I don't think I've actually got an answer guide for that one, but I can draw it up. Or if you guys like to, once you've done it, email it over and I can have a look at it. Because as I said, there's lots of different answers, especially for this one here. We can do it lots of different ways. So I thought that's what we do for the next half an hour. If anyone's got any questions about anything else, definitely use this time to ask me. And for those guys who think, hey, that one's a little bit too hard for me, let me know and I'll draw something up now and scan it and send it over, and you guys can have a crack at that one as well. So is there anyone who finds that one a little bit tough and they want to do one a little bit easier, just like a straight, rectangle? Yep, cool, no worries, Greg. I'll catch you later. No, so happy to have a crack at it. Cool, thanks, mate. Yeah, so if you're happy to have a crack at it, if you've already done it, then by all means, there's probably no reason to hang around unless you want to ask me about some other stuff. But yeah, have a crack at it and let me know. And if you've already done it, then drop in next week when we do our wall framing. Yeah, I will, Valorant. I just don't think I've got an answer. I just had a look. I haven't actually got an answer for this one. So what I'll do up an answer for that and basically send that over so at least guys can sort of see how it looks. I don't actually know what's happened to my version of it. You can probably hear me flicking through the pages. I seem to have lost the version that I did. So yeah, bear with me a second, mate. I'll see if I can find it. And if I have got it, I'll basically go through it. If not, I can probably work it out quickly. I just won't have anything visually that you guys can look at. That's all. What I just did, Valorant, I've just printed one out, and mate, I'll see if I can draw that up in the next half an hour while you guys are doing yours, and then I'll scan how I did mine up, and then you guys compare it to the ones that you guys actually did, if you like. Yeah, it's cool, mate. It is pretty tough, this one. Guys, I'm just going to be gone for about 1 minute. I'm just going to go and grab my ruler and textures so I can draw this in and make a bit of sense out of it when I scan it up for you. So if you've got any questions, just chill out for about a minute. Hey guys, this is going to sound a bit funny, but I've just printed mine out on my home computer. I didn't have any actual A3 paper, and so it's actually to a scale. Is someone able to help me out with actually what the measurements are on it? Can someone, if you've got your ruler there, just tell me what the length of this first wall is across the top here? Either whether you tell me or you just type it in the box. So that's 13. So is that 13.4 from the garage to the end, Subit, or is that the overall measurement of the whole thing? Overall 13.4. Cool. Thanks, mate. And then 8 meters the other way. Thank you. Okay, Valavan, I'll just show you what I've done, mate, so you're not sitting there waiting for ages. This is how I would do it. Okay, so the first thing that I've done is just started to draw in where my bearers are going to go. So the bearers always go basically the lengthway of the building. So I'm going to put one on the external, right along that wall there. If you can you see my mouse when I'm moving it, Valavan? You can see the little hand. Is it a hand on your end, or does it just show as a cursor?
Yeah. I can see the hand. Yeah.
Cool. So I'm going to run one basically, pretty much next to that brickwork. We'd have a little bit of a gap for our cavity, but for this purpose, I've drawn a bearer basically all the way along there. So I would get one here in front of me. And then basically I've drawn, I will put one here, but I haven't done that yet. I want to work out what my spacing there is. So the next one I've drawn is basically underneath that wall, basically all the way through under that wall from one end to the other. Then I've drawn another one straight under that wall from one end to the other. And so if you want to draw this, I'll wait until you've got it drawn so I don't go too fast for you.
Yeah, I'm following you. That's fine, Adam. Yeah.
And then what I've done, I've drawn one here, basically this length of this wall, basically all the way through. Without knowing the exact measurements, in reality, you probably could not have to put it through there if you didn't want to, but I just put mine all the way through. And then I've done one basically in this little part here as well, parallel with that brickwork, basically in with my 25 mil for the cavity. So that's, because I just know that's where they have to go. I've obviously got to have one on the outside. Oh, you've done it, have you, Subit? Excellent. Let's see what Subit's done for me. Excellent. Subit just said he's done one and he's emailed it over.
You are a legend, Stuart.
There we go. Let's go. Oh, how good's this? So, yep, that's pretty similar. So I'm just trying to see. So yeah, as you can see, yeah, with Subit's measurements, I've done mine high-low, but basically he would have one basically along this line of the wall here. And what I've done is then done one underneath that load-bearing wall. As I said, then one under that load-bearing wall. Then one down the edge down here. And then one basically inside, and those boxes keep popping up, sorry, down there. So once I've actually done that, because I know they're the critical points where it's got to go, because it's a what they call a conventional roof, I know that I've got to have some sort of strutting coming down onto my internal walls, so therefore I need to support underneath those internal walls with a bearer underneath them. So once we've got those in, really all I've done then is tried to fill in the gaps. So looking at Subit's measurements here, that because we've got one drawn just here and one there under those load-bearing walls, the space in between those is actually 3.3 meters. So if we wanted to, we could have gone out and just run one straight down the middle, but then they would have been at 1650, the spacing between the two, and so there's nothing wrong with that. But what Subit has chosen to do is actually try and keep it under 1500 millimeters, and therefore he's put two rows in there. So therefore now that'd be at 1100 millimeters. So that one there would be 1100, that would be 2.2, and then 3.3 to the next one. So that's what he's done. So then on this part here, he's measured from his outside bearer to that one under that wall was 1850. So same thing again, he could have kept it at 1850, but he likes to keep it under 1500. So what he's actually done is then basically taken one straight down the middle, which would then give that a spacing of 925 millimeters. Then over to here, what he's done, so I can't quite read, I think it might be 2500. Is that 2500 there, Subit, or is that 2800? Might make that a little bit bigger, I might be able to see it. 2500. Yep, so that one there, from that bearer running down there to that load bearing wall was a space of 2500. So if he puts a bearer straight down the middle, his spacing then is only going to be 1250. So that's why he's run his bearer all the way down there. And he looks like he's run this one straight through here as well. So that's how he's broken it up. So you can see there, they're not all exactly the same. But he's kept them all under 1500. So you work out your critical points, which is, I'll just make that a little bit smaller again. Oh, hang on, I'll just, I don't know how to get a different percentage. What was it? Can I type it in? Yeah, good. How good am I going? So, yeah, so you work out your critical points, which are your external walls, and then basically underneath your load-bearing walls, and then just fill in the gaps. And I said it's really up to you what you decide you want them to be at. I said I just always try and keep them under 1500. So that's why he's got that one there. The spacing would only be 925. These ones here at 1100, and these ones here are about 1250, but they're all actually under 1500. So then what he would have done is then just worked out his overall length. So that's actually his bearers. He knows his bearers are running horizontally where those lines are. So then the next thing he does is work out, okay, these little squares are actually where Subit's stumps are going to be. So the exercise that I did before at the very beginning of the session was that the length of that wall is 13.4 meters. So I dare say what Subit's done is gone 13.4 divided by 1.5, and let me bring up my calculator and I can do that on the screen, and we probably will get the same as what Subit got. Just give me a second, I'll open up my calculator. Is it going to move for me? No, I can't move with that there. Okay, so the length of that wall was 13.4. So I'll do it in millimeters. So 13,400, that's 13.4 meters. We're going to divide that by 1,500 because we want to have our stumps at approximately 1,500 millimeters. So that's going to equal basically 8.99. So we're going to round that up to actually 9. And so we're going to then add 1, and that means that we need 10 stumps to cover the whole thing. But it means there's only going to be 9 spaces. So when we want to work out actually how far these are spaced, if we go that measurement again of 13.4, and we divide it by 9, so 13,400 divided by 9, because there's 9 spaces. Is that right, Subit? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now, Subit's gone a little bit more. So he's obviously gone on his 11 spaces. I said, which isn't, there's nothing wrong with doing that. Subit might have gone a different spacing to try and do his time with the type of footing system, or with the footing number that footing type he wanted to use. But yeah, so I might just check those measures, make sure I didn't do it wrong, because I got different what Subit did. But as I said, because I got them different doesn't mean that either are wrong. So 13.4.
Adam,
Yep.
Subit here.
Adam,
Yep.
Subit here. I was trying also trying to pay attention to the those corners of the garage, trying to line up with the corner. Is that important to do that?
Which part, mate? You mean these parts coming through here?
Yeah, and also down south here, there's a bit of projection. So I was lining up the stump point to that in terms of bending. Would that be important?
No, I don't think so. Correct me if anyone here can see a reason why, but I don't think so. Because realistically, basically your joists are going to sit straight on top of it, and then you're flooring anyway. And no one's, I wouldn't see there would be an issue. Like some people might try and, run this one along here so that this bearer that was on the inside of this wall basically went all the way through. So you might be able to find if that measurement from there to there was, 1.2 meters, they might find that easier just to run that bearer all the way through rather than stop it there and then basically have that halfway in between. But it doesn't really matter, mate. There's really horses for courses, whatever's going to work for you and make sense to you. As long as we're not going beyond what our capability of the actual bearer is, it's not wrong. And that's obviously what you've chosen. I can see that's what you've done now, because you've tried to obviously have that come all the way through. But yeah, to me, I wouldn't have done it like that, but it doesn't mean that it's wrong if that's the way you've chosen to do it. But I wouldn't personally see any big benefit in having
I was trying to line out the corners, so it ended up to have a smaller span in a way.
Yep.
Yeah, so sort of more stump points.
Yep. Yeah, exactly, and that's fine. And that's I must admit, like when you look at this visually, it just looks great because it's all in line and it all lines up. You look at it and go, wow, it looks very symmetrical. And that's another thing too, with you saying that's how you try to do it, Subit. And there's another thing too where you can see the way that I worked it out, that I was, I think, only going to put, 10 posts in, and Subit had, give me a look, 1, 2, admittedly that's an engaged pier, but now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So Subit's gone 2 more than me. As I said, by all means, that's not wrong, but you can start to see probably once we start sort of, I suppose, over-engineering it a little bit, the extra costs that might start to have on the project. So if Subit's got, how many rows of bearers? 1, 2, 3, 4, 5, 6, 7, 8. He's got 8 rows of bearers, and then he's got 2 extra stumps on each row. So realistically, Subit's plan compared to mine, he's going to have 16 extra stumps in there. So that's going to be 16 extra holes drilled by the auger, then 16 extra concrete stumps, and then all that concrete to go with it. So that's one thing too that I suppose when they start to actually get designed, Subit's just got in there, he'll probably make a loss on the job. Not so much of a loss, because you would quote that and factor that in, and that's where we sort of want to, I suppose, but basically make the job as structurally sound as we can, but then also we need to be mindful of the commercial aspect and go, okay, are we competing with other guys? And if someone's undercutting me by I don't know, making this figure up, $10,000, yeah, that could possibly be because we've got all this extra timber and concrete in there. And so they're the sort of things, I suppose, too, we want to be slightly wary of once we're doing our designs. But as we've spoken about before, it's very rare we're going to design this anyway. It's going to be done, you know, for us, and we're going to quote off it. So it might be something you might, you know, have in the back of your mind that, you know, if you did quote on it and you were the only one quoting on it, and the person, you know, was a referral job, and the client said, oh, look, it's a bit too dear, you know, what can we actually cut off to make this a bit cheaper? This might be something from your experience by knowing how to use these standards, by actually talking to the designer, saying, hey, listen, I know we can actually, you know, basically do this and space this out a bit further. It's going to save 16 stumps. Can we do that? And that might be something, you know, from your knowledge, might be able to save your client a bit of money, I suppose. Because, yeah, we're not going to be actually designing this stuff. And I've seen that done when I was on site, mainly when we were doing to be designed, and we used to do, when I was in Queensland, a lot of lifting of homes and building in underneath. And we would see the plans and look at it and go, it's going to be a lot cheaper, you know, to put an I-beam in, or basically what, you know, whatever scenario we thought would be cheaper, and we would quite often float that to our engineer and say, listen, mate, this is what's been designed. How would you feel about it if we did it this way? It's going to save, you know, $5,000. It'll save me a lot of time. And he'd go, yeah, there's no worries with that. And that's sort of where the experience comes in a little bit later on, because as we've seen here with Subert's drawing and how I would do it, different. They're different, but they're both right. So, yeah, so sorry, Valerie, back to,
Adam.
Yep.
Just ask him. And I heard that some people sometimes, you know, like when they have like 9 spaces, they add 2, because one for the start and one for the end. And if that is the case, we are doing the extra work, right? I mean, extra spending on that.
Yeah, no, you've only got to add 1 to the start, because if you, the way the calculator works it out is, if I divided this by 10, the way that, let's just say hypothetically these were all spaced at 1 meter. So when the calculator works out, it goes, you know, 1, 2, 3, 4, 5, 6, all the way down 7, then it goes and gives us our 9. So it will always finish there, but it doesn't give you the 1 on 0. So you've only actually ever got to add 1. You don't actually have to add 2. Sometimes people do adding 2 if they're doing joist, because there's going to be a double joist on each end. So that's sometimes why people actually add 2, more so for joist, not so much for stumps, if that makes sense.
Okay, yep.
Yeah, because if you look at your Australian standard, and I've closed it down, but in the Australian standard, when it shows the joists underneath our load-bearing walls, you normally see there's 2 joists there. So that's why people quite often add 2.
All right. Okay. Thank you.
Yeah. Cool. So yeah. So back to what we were doing here, Valavan. I said and so what I would have done was divided that 13.4. Sorry, divided by. Just 1 sec. I'll clear that. So the length of the building was 13,400. I've divided that by 1,500. And it told me that, yep, there was going to, we ran it up to 9, and then obviously add the 1 for the beginning, so it's 10. So if there's 10 stumps, there's only going to be 9 spaces. So what I'm going to actually do to work out my spacing is then divide that length of the wall divided by 9. So 13,400 divided by my 9 spacings. And therefore, yeah, my spacing of what the way I worked it out would have been 1488.88. So that my stumps would have been, they wouldn't have looked as symmetrical and nice as Subert's, because they would have just been every, you know, 1488, and that's how I would have worked them out. And so once we actually did that, I'll bring up my Australian standard again. So bear with me a second. So then to work out the size of my bearer, I'm going to go to that span table at the back. Just going to shrink that a little bit. So the span table, so I'm working out bearers supporting single external load-bearing walls. I just have to see, mate, if it was a sheet roof or if it was a, no, it was a tiled roof on this one. So therefore, with that Australian standard, I'm going to have to go bearers supporting single-story external load-bearing walls with a tiled roof and a continuous span. So this time we're going to table A6. So I'll go down to table A6. and because it's got a strutted roof on it, so our rafter span, because the building itself, and I'll just bring this up, so the building itself is 8 meters, but because the ridge runs right down the middle, the rafter span itself is only going to be, about 4. So it's, basically that's what it's going to be. So if we come back to our table, got so many things open I can't find it. So it's going to be bigger than 3 meters. So it says it says strutted roof, maximum raft. Oh yeah, so what we're going to have to do, this is where it gets a little bit difficult. Sorry, I've explained that incorrectly. So I'll go back to this picture. So whilst that is basically over, because that's just triggered my memory when I did this last time. A lot of people say, hey, this table can only actually do rafter spans up to actually 3 meters. But what happens when we basically come back to this picture, because that's a load-bearing wall, that's actually going to break the span of that rafter. It will actually be supported in the middle. So when we look at our rafter, it's got that support underneath, which I'll show you a picture shortly, which then breaks down that rafter span to about 2 meters. So that's why we can actually use this table here, and I'll show you that picture shortly, guys, if you're still watching. Right, so we're going to use this table here because it's a strutted roof, and because we're breaking up the span of that rafter, it's not going to be any more than actually 1,300 millimeters. So I've worked out that my bearer spacing was under 1,500 millimeters. My bearer span was 1,488 or something, so I'm going to use that one there. And then all I'm going to do is basically come across to the timber type that they want to use. So I'll just see what that timber type was. And it doesn't actually say. We'll use what have we been using so far? I think we've been using F17. So if we're going to use F17, it's 290 by 35. So like we did before, I worked out my bearer spacing, then I put my stumps in to see how far it was going to span, and then just lined that up with the right table, and basically F17, that's my timber size. So just to go back a little bit to why that got broken up with the span of the rafter, I'll just show you that how it works. So bear with me a sec. I just don't know exactly what page it's on, so I'm going to have to find it. I'll find something on roofing. So see that there? So that is when I come back to this picture, that load-bearing wall there is basically what is happening here. So there's a load-bearing wall there, and there's a strut coming down onto that, which is transferring the load of the roof down on that load-bearing wall. And so as per our diagram, that distance on our picture back here to the center of the roof line is about 4 meters. And so when we went to use that Australian standard table, it actually told us we could only do up to 3 meters. But because we've actually got this being supported in the middle, it actually breaks that span in half. So that's why we're actually able to use that table. So yeah, that's why, if you're wondering why I used that table, that's sort of what we did. So that drawing, guys, if that has confused you, it is very confusing. And what I'll do, I might actually make up a couple, and they won't be nearly as confusing as that. And what I'll do, I'll just do some basic shapes, and I'll drop the answers of how I would do them, and I'll email them out, and you have a crack at them in your own time. And once I'll do, probably, it won't be tomorrow, it'll probably be, like always, I normally sort of get to do stuff on Fridays because I train 4 nights a week at the moment, and I'll email it out with just some random sizes, put a bit of a scenario there, and you guys work it out. And then if you're still struggling after that, just let me know, and we'll make sure that we put some time aside to actually make sure you guys understand it. So what I'll do, I'll leave it there tonight unless anyone's got any questions I want me to run through. But yeah, so this is by far, I think, the hardest subject that we do, and especially with the limitation of being online. If you haven't done it face to face, it's a bit hard for me to sort of look over your shoulder and say, okay, now do this, now do that. So I just want to make sure you guys do actually understand it. And if you've got any issues, just make sure you get in contact with me, and we'll do some sort of one-on-one session, over, or come to class early or late on a Tuesday night, and we'll actually make sure that we get that done and understand it. So what I'll do there, guys, I'll actually leave it at that, and I'll just hang around if you've got any questions. And I did actually just get yours there too, Tom. I'll have a look over it, mate, and I guess it's popped up now. Give me a look. Yep. So that's, yeah, if you don't mind, Tom, I might actually show that one. That looks similar to how basically I did mine. I'm sure Tom won't mind me sharing that with us because it's looks pretty good. So let me make that a little bit bigger. So that's the one that Tom's done. So that's sort of similar how I did mine. I went straight underneath these load-bearing walls, down basically the side, and down these sides. And I actually went straight through like that as well. Put another bearer in there, and then basically just split my gaps here to make sure they didn't exceed basically over 1500 millimeters. And you probably see there, I don't know if it's just the way Tom's drawn it or whether he actually intentionally did it, but he's offset that bearer a little bit. And as we spoke about before, there are distances of how far we can offset those walls in relation to where the bearer is going to be. And so, yeah, he just said, yeah, they're less than 1.5 times the depth. So he has done that intentionally. And then he's been able to space, you know, pretty much everything. These ones are at 1500 and that whole distance there is at 2500. So that'd be 1250. And that's, yeah, basically how Tom's done this. So if you're wondering what he's done here, these are actually engaged piers, guys. So that's why he's got his crosses would be what his where his stumps would be, and these ones here would be his engaged piers, the brickwork that is basically his bearer is going to sit on top of. And he's just gone here that he's done a footing type 2, and he's done in the size there, and then his joist size that he's gone was a 70 by 35 F17. We didn't get to the joist, and those bearers I'm pretty sure is exactly what we got as well, was 290 by 35 F17. So yeah, if anyone else wants to send theirs over, I'm more than happy to have a look at it, but that looks pretty good there, Tom. And yeah, so I'll draw up those exercises and send them over later in the week. And if you've got any questions, then just give me a buzz. But yeah, I'll be hanging around if you've got any questions about tonight or something that didn't quite sink in. And otherwise, I guess I'll see you next Tuesday night. Cool, thanks, Valvan. And we'll definitely give you some more stuff, mate, too, so that you totally grasp it.
Thanks, Adam.
Cool, mate. I'll catch you later.
Yeah, thank you. Thank you. Thanks, everyone. See you.
Thanks, Dean.